see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to...
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to...
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to...
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
see's my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
All right, welcome to the Testing Localhost track. Thank you for being part of TestJS Summit 2022. Enjoy the talks, and don't forget to ask questions afterwards on spatial.chat or on Discord. Our speakers will be extremely happy to answer. And our first speaker is Philip Rick. So huge virtual applause for our first speaker on the Testing Localhost track. Philip will be speaking. His talk will be on full circle testing with Cypress. Philip is
clicking, typing, interacting with my page. Basically, what I want to do is to go to my homepage, create a new board, then create a new list, and inside it, create a new card. And this is what the flow automates. So whenever I make an error, for example, I change my selector to not be found, and when I save my test, it will automatically rerun. And if I make an error during my test, I get this really nice assertion error explaining to me what actually happened. So in this case, what actually happened is that it couldn't find the selector because I made a typo on it, and it was nowhere to be found. Cypress is actually going to retry searching for that selector for 4,000 milliseconds, for 4 seconds. Now, this means that Cypress works really great for the applications that are all the time re-rendering and doing some sort of fetching from API, etc., as modern applications do. So when you are testing, you get this instant feedback into what your test has done. But also, the important thing here is that we are running inside the browser. So while we are doing that, we get all of the advantages that browser will provide us. So for example, we can open up a console and take a look into what's happening inside the console. So I'm getting a couple of warnings here, but these are not that important. Cypress actually takes a great advantage of the console and of the fact that we are running inside the browser. So when I click on any of my commands, for example, this visit command, Cypress will print out information into the console with the details of that command. It will also print out information for every HTTP request that is being done with the application. So let's maybe fix the test, save it to make it pass, and also what Cypress enables us, as you can see, is to sort of travel back in time and examine the application as it was looking while the test was being executed. So this is pretty neat. This gives you an insight, and especially if you're looking for a selector that is kind of hard to find because the element appears and then it disappears, this is really helpful tool. So you can see different API calls, and Cypress sort of invites you to get into the application and examine the application and get to know its nuts and bolts. So a great area to start examining your application a little bit more is to do API testing. And this is actually the second part of our circle of tests. So when we are doing API testing in Cypress, we can use a command called request. So let me show you that one. And let's change it because I'm going to show you the API command in just a second. So let me save my test and let me open that in my Cypress runner. And oops, sorry, that was not the correct test. We want to run the API testing. All right, so now we have it. So inside here, what I'm doing is using the request command to send a post request to the URL of API boards. So as you can see, the syntax of my test is pretty simple. I'm using the CY global object, which is available throughout the whole test suite. And I'm using the request command that is there for sending API requests. So of course, what I'm doing is sending the post API, and here is the body that I'm sending towards the server. Now, when I get a response, I take with the its command, I'll take the status and make sure that it is 201. Now, how do I know to look for the status and for the contents of the response? Well, the first way of how I can look into that is to click on my command, and just as I showed you a couple of seconds ago, open the console and examine what the command has yielded. So with my its command, I have actually taken out the status and then checked whether the number of that status is 201. So it is, and my test is passing. So this is really cool, right? But I see a little problem here. Maybe you see that too. We have that big white space over here, which is not used for anything. So that's kind of not so good, right? So what I did with that is I got inspired by the open source community, and namely Gleb Bahmuto, who has built a plugin for showing the API in the browser, and I have made sort of my own version of that. So I have this installed in my repository, and what this plugin will do is that will add a new command to the Cypress library. So I'm going. It's called API, and it works exactly the same as CY request. So when I save my test, it will print out the information about the request into the browser. So I can see the method, I can see the URL, also the status, and I also see the request body and response body and all that information. I can even copy. I can even copy the contents of the response body to the clipboard, and maybe I can just try to write a test. So let's go with its body, and let's do deep equal, and I'll paste my object over here. I think that should work. Let me save that, and yeah, we're good. So we are testing the API with our shoot command and with a visual feedback that we got here. So as I said, Cypress is known for end-to-end testing, and as you can see, it's a great tool even for API testing. So what we can do is we can combine these two worlds together. We can do end-to-end testing and API testing. And since all of the requests that Cypress sends are actually sent from Node, so they are not sent from out the browser, what we can do is to call any API we want. So actually I have a test over here. Let me show you that one, where I'm testing an email. So let me open that one, and let's explain what's happening in here. So I'll go through the timeline so I can travel back in time and guide you through what's happening. So I'm visiting a sign up page, and then I'm filling in the email and the password, and I'm checking this nice little checkbox. So let me show that to you. And this says, send me a welcome email. So what this application will do is that it will actually send you an email if you check that checkbox. And what I can do with my request is to access the mailbox that I'm using with an API request. So there are different kind of tools that enable you to access your APIs with HTTP requests. So one of that is TestMail, but we got Mailosar, Mailslurp, and other services that provide this feature. So that's exactly what I'm doing in this test. Although it may look like a little bit complicated, it's actually not. I'm just generating a random number over here. I'm assigning it to a variable or an alias, and then I'm using this alias as a part of my email address so that it can be identified on the server. And then also I'm using that tag in the request itself as a query string. So when I send that request, I get the content of the inbox as a response, and I'm checking the body emails, and I'll check the subject of that email to be welcome to Trello app, which is exactly the subject of that email. So yeah, that's pretty powerful. But you probably noticed that when I'm going over to timeline, that Cypress actually takes notice of all the API requests that are being done by the application itself, which brings me to another area of API testing, which is network layer testing. So not only we can send requests, we can actually observe the request that our application is doing. And let me show you on the example that I have prepared for you. So I'll open another test. That's going to be network. And I'll filter out the first test using dot only. Maybe you know this trick, maybe you don't, but if you do dot only, you can filter out the only tests you want to run. So let me save that, open the test, and you can now see it in action. So what's happening here is my test is actually failing. So let me walk you through that. Inside this test, I'm using the intercept command, which, when I explain this on my workshops, is something that tells Cypress to watch for a certain request to happen and to be called by our application. So this request is actually being called, the post API boards is actually being called when we create a new board on our page. So when I go to my homepage, fill in the details and hit enter key, that's where the API is being called. And this is exactly the place where that happens, and we have that highlighted in Cypress. I have aliased it with a name of create board, and here is the alias. So what I do after I do the action, after I type in new board and hit enter, is that I wait for this API request to happen, and then I'm testing the request body name to have a certain text. And as you can see, this test is actually failing because my input is adding a white space after my input. So whenever I hit the enter key, it will register that as a new line, and it will add that /n sign into that, which is not good because I'm polluting my database. This demonstrates that I can not only test the response, like 201, 202 or something like that, I can actually test whether the application is doing what it should be and whether it is sending the proper data to the server, which is great because now for API testing, I'm not using the direct requests that I know how to prepare, but I'm actually testing whether the application is sending the proper data to the server and checking if it's not sending some corrupted data or doesn't handle the inputs properly as it does here. So what Cypress and the intercept command actually enables me as well is to check for different edge cases. Not only I can observe a API request happen, I can also sort of cut off the server response and provide my own. So what I can do, I can change the body, I can change the response status, I can even change the response time, which is exactly what I'm doing over here. So I have a callback and I'm handling the reply to sort of be delayed by 10 seconds. So when I now save my test, you can see that the API boards request is actually taking a longer time, and I have this reload button being shown in the application, which normally would be a really hard place to sort of reach and to test, but with intercept we can actually show that and see if it behaves properly, if it appears after 3 seconds as it should, and if it works properly. So we can actually click on it and make sure that our application will reload. So with the testing of network layer, we can sort of get to different hard-to-reach edge cases. And one of the great examples of how we can reach different edge cases is testing the application layer. So that's what Cypress enables you to do as well. And that's what I want to show you. So in this example, I'm using something that's called app actions. So let me change this test a little bit. Save it now and run it. All right, I got it. So Cypress takes a great advantage of the fact that it is running in the browser. I've already shown you a couple of those, like printing out things into the console, taking notice of what the application is doing on the network, but also you can take a look directly into the application state. So let me show you in the application. I have this store.ts, which this application uses Pinia. It's written in Vue, and for store management, it uses this Pinia package, and it uses this use store. So inside here, I have all of the state or all of the default state defined, and I also have defined some of the actions that mutate this state. Now, what I have done with my application to make it more testable is that whenever we are testing, whenever there is Cypress on the window context, we are exposing the use store, so the whole state of the application, to the store variable on the window object. So what this enables me to do is to access the properties of the store and even the functions of that that mutate the store right from the window context. So in Cypress, I have this cy window command which accesses the window object, and then I can invoke different functions. So here I'm invoking the store, and then I'm invoking the getBoardList function, which actually triggers the API call for fetching all of the boards from the database. Inside here, I also have a pause function. So maybe even if you are using Cypress, you haven't heard of that one, but it's super useful when I'm demonstrating something. So inside here, I can just go step by step and move on to the next command, which is API call. So I'm creating a new board, but as you can see, it is not appearing in our application. And this is because we don't have some sort of WebSocket connection to the database or with the server that would update the contents of our application. We would basically need to reload the application to make that get API boards call to be triggered again. But with app actions, we actually don't have to do that, because we will invoke the store and then call the getBoardList action, which is responsible for fetching all of that data from the server, and which is the function that gets called whenever we open the application. So let me go to the next step. We get the window, we get the store, and now we call the getBoardList, which will trigger this API call, and our board is now loaded. So with app actions, we can access all kinds of stuff. We can even access the things that are hidden from the application. So let me comment this out and show you this, because I have some hidden API tools that I made for this application, and now I'm basically calling toggle tools to appear, and I have this nice neat API tools available for me here, and I access this using the invoke and using the internal store of the application. So this is a huge advantage compared to maybe different test automation tools, because since we are running in the browser, we have direct access to the application. That's opposed to tools that sort of drive the browser and access the browser sort of from outside to automate actions on the browser. Now, of course, this has some advantages and it has some disadvantages, but I view this as a really big win for Cypress when it can basically access any part of your application that you give the authority to, and and manipulate it in a way that helps you reach maybe a hard to reach edge case or some part of the application which might be hard to set up because of the data or because of some other factors. Now, Cypress is of course a great tool for getting into the app and testing different states and making the app do stuff so we can test it in a better way. But we can dive even deeper and break down our application into smaller chunks. So Cypress has released this killer feature called component testing. So it recently got out of beta. It has been here for quite some time, but with versions of Cypress 10, it reached the whole crowd. So I want to show you this, because our application is sort of built from different small components that make our application. I like to think about it as sort of Lego blocks that are used to build the application. So in here, I'm basically using CY mount function that is going to render my component, and I'm passing different properties into here. So if I type hello world, my button over here is going to render hello world. If I type hello test.js, it's going to render out this. So I can test different kinds of states of my component, and it doesn't have to be button. We can go to something more complicated. So for example, we can test different states of our notification in here, test an info message or an error message. Or we can go to our navigation bar, click this home icon, and see if it behaves differently when we are at home or when we are at some other sub-page. We can even render out sub-components. So this drop-down items actually contains some slots with components in them, and you can go basically anywhere with this. The biggest advantage of this one is that we get to render our components inside a real browser. So this is exactly how our components would be rendered inside the browser. And we can interact with them, we can test them, as you can see, and we get all of the API of Cypress enabled for us, so we can test different states. If the component calls an API, we can use intercept to sort of change the state. We can test we can send requests, we can we can change the state of the app using the app action that I have just shown you, or we can just render multiple components and see how they interact with one another. But if you are doing that, you kind of reached the full circle and go back to end-to-end testing. So you can go all around as many times as you want, and hopefully you get a good coverage of your application. This has been really fun, so thank you very much for listening this far. I will be really eager to meet you on one of my workshops, whether on TestJS Summit in here or in November on my other workshop. You can find a link at the bottom of this presentation. And now I'll be looking very much to hear your questions. See you in a bit.
Many thanks for Philip for such a great talk. Remember to join spatial.chat to talk to Philip and ask questions. And I would like to have a big round of virtual applause also for our platinum sponsor, Sauce Labs. Sauce Labs offers the leading test and error reporting solutions that identify issues across the software lifecycle, giving the visibility and insights that enable its customers to achieve high quality and high velocity releases with confidence. And now I would like you to meet our amazing Leah Moreira, our next speaker. Leah's talk will be how to choose an automation tool. Leah is a physicist, A ballerina and a programmer, she started her journey doing some investigation work on particle physics, implementing algorithms. When she finally chose to turning into software development, could be a good fit, she moved to full stack development. And when unit testing appeared in her eyes, she knew that programming with testing was the way to go. Now she dedicates her day working in automation testing, QA work, studying a lot about how to improve her work and dance. Leah, the stage is yours. Welcome.
I hope everyone is feeling good, and before anything, I want to thank you all so much for being here today. I am Leah, and I'm going to show you a process that you can use to choose an automation tool. I am going to do an overall comparison of 3 frameworks that I think are the best at this moment, and I'm going to talk a little bit about other tools that you can integrate in your automation process. So a quick insight into who I am a software engineer. At Nokia, my main focus is on test automation, and let's dive into this. So this is a 3-step process, like all the good ones, of course, but each step will need attention and work. So let's move on and dive into the first phase, that is analyze. So analyzing means answering some questions, and the first one is not really a question, is understand your application. So look at it and be really critical about it. Try to understand what are the weak points, the features that you can break more easily, and try to think of edge cases in the application. So just have an overall picture of the application that you are going to test and make a list. Make a list of the tests that you want or need to do. And at this moment, it will be a good idea to talk with the development team and try to understand what are the coverage of unit testing that they have, if they have. And knowing their coverage, you can avoid duplication of work by your side. And if they don't have unit testing, it's a really good opportunity to meet with them and with the management team and think of a way to do a coverage since the develop until the production. And this means that have automation tests in all parts of the process. So the development team will have unit testing, and you can have end-to-end security, accessibility, whatever types you think that are more suitable for you. So having this, you will need to ask yourself if you want to code or not, and ask your team if they feel comfortable doing this, and in which language do they feel they will be more comfortable working. So having this, you will end up with a list more or less like this, in what you have the development team has unit testing or not, what type of tests that you are going to do, and you will have a language that you feel more comfortable working with if you choose to code. So if you do not want to code, there is not a problem, because here we are inclusive and we have options for everyone. And if you don't want to code, I will give you 2 options that I know, and be aware that I believe there are a lot more options for you. So if these options that I'm going to give you does not suit your or accommodates your needs, just search for it. And we are kind of entering here in the next part, that is search. But I'm going to previously tell you about Testim and Perfecto. And these 2 are similar in the things that they can do, but just in a quick explanation, these 2 record your manual testing, and for each action that you do in the browser, they make a block. Sorry. And when you finish, you will have your test case and your automation, that is a group of blocks. And just like in coding, you can create a group of blocks that you can reuse between tests. You can create folders to run in each deployment. You have a full group of options that you can have, just like in the coding. So if you don't want to code, just take a look at this too and dive into this, because I'm sure that you will have options for you as well. So if you do want to code, I'm going to do some comparison between Selenium, Cypress, and Playwright. And this is more or less what you're going to do in the search part with the frameworks that you choose to compare. And for Selenium, starting with Selenium, Selenium is a framework that is here for a long time. And this means that Selenium has a large community supporting it. And you will not be alone working, because you will have Stack Overflow to help you with a large group of people that can help you. And overall, it is a really good framework, but it will need third parties to work with certain types of tests. So Selenium automates the browser, so it simulates a real browser interaction, meaning that if you need to do API testing, you will need to integrate with a third party to have the API testing. And since Selenium does not support by itself parallel testing, you will need to integrate with Selenium Grid and a cross-browser tool to make it work. And for me, the most downside for Selenium is it does not have an inbuilt report tool, so you will need to have a third party like X-Ray or TestRail, that I'm going to talk a little bit in the end, to support this. And it does not support iframes or pop-ups. So if your application depends on third parties iframes, Selenium is going to be a really not go-to framework. But if this is something that you can live without, Selenium is really good to work with a large set of tests. But like I told you, it will need third parties integration for some type of tests, and this will make it more difficult to work in the beginning. I'm not saying that it's impossible, because nothing is impossible, but you will need to have some experience and some expertise to understand what are the workarounds that you need to do here. Okay, so it is a good tool. If you want something easier to start with, let's move on to the other two and understand what are the difference here. So with Cypress is an all-in-one tool, meaning that you can have the development team doing unit testing and you doing the other types of tests in your side, and have the whole team working with the same framework. And this is cool because you can take doubts with each other and try to understand and review code from each other. And it is very complete. It has an inbuilt report. You don't need to integrate with any third parties here. But the downside is that you only work with JavaScript here, and it does not support parallel testing and multi-top testing, meaning that if you need to have certain types of configurations that need to be run at the same time, example, if you want to have a browser with a device and various configurations about this, you will need to run them separately. So it will be a very huge time running the test case. So if you need to have various set of configurations here, various environments running at the same time, you need to consider if Cypress is going to be a good tool for you. But for starters, and for a small, medium group of tests, Cypress is really good. It's a very simple tool to work with if you work with JavaScript, of course. It is a very simple tool to work with, and it has a lot of documentation. The community is growing, so you will have help with Stack Overflow for any type of doubt that you need. But it has its downsides, just like all frameworks that you will encounter here. Moving on to Playwright. Playwright is a fair new framework. The first time that I heard about it, it was here in 2020, if I'm not mistaken. And it is, I think, the most complete of the three. You can have all types of tests running in Playwright. It supports parallel testing, so you can have various sets of configuration and environments running at the same time. It has context isolation, so you can have tests for new tabs and clicks for open into a new tab. It can capture videos and screenshots, so you can have visual testing in comparison, but it is a new framework, so be aware there are some types of features that are not completely developed. So if you look for a framework that is settled, maybe Playwright is not the go-to. And since it is a new framework, the community is not very large compared to the other two, so you will need to have some experience with coding and expertise programming and searching for things, because you are going to be a little bit alone in this, because you have the community of Playwright taking doubts, but Stack Overflow is not really filled with questions and answers for how to move with Playwright. So be aware that you will need to take a lot of time trying to move with Playwright. And the documentation is a bit confused, because since it does a lot of things, it's kind of messy to work around with. But if you want to take the time to work with a framework that does it all for itself, I think it will be very good to work with Playwright. So just in an overall of these three, I think that you need to choose what you feel comfortable with. So have a look at the three, just play around with each one of them if you have that time, and choose one that you feel comfortable working with, because this is something that you're going to work with like 6 hours of your day. So don't choose one because your friend told you that this is the best, or I tell you this is the best. Just choose one that you feel comfortable and that fulfill the most of the needs that you have for testing an application. So moving on to this, you will end up with a board, or you should end up with a board more or less like this, where you have the type of test that you need at the left, and check and cross or ups and downs of the framework that you are comparing. And just in a side note, each one of them has options to work with accessibility tests. The one that I know is Axe, that you can integrate with the frameworks, and you can have apply tools to each one of these three to run visual testing. Have in mind that Cypress and Playwright do this by itself with screenshots and videos, but if you want to have a third party working with this, you can work with apply tools. So after this, you will choose or not a reporter, and this is going to be a quick comparison because I don't want to go very deep into this, because I think that choosing a reporter is not a decision of the quality team only. It should be a decision of all the product team, because everyone should be integrate it in the process. But just in a quick comparison, X-Ray has integration with Jira. TestRail also has integration with Jira, but it's not so obvious that it's there. And X-Ray, you can create test plans, test execution to integrate with the issues that you have in Jira. This having in mind that you work with Jira. If you don't work with Jira, this is not a very good option for you. But in my opinion, X-Ray is a more integration tool with Jira, and to be visible for everyone in the team what is being testing and what is being doing for the quality team. And TestRail is more on the downside. So if you want a tool that the quality team will work with separately from every other team, I will go with TestRail. And if you want a tool that is more integrated with the process and the product team and the development team, I will go with X-Ray. But moving on to the plan part, that is the important, I will not say the important, but the part that you will have to take a little more time to understand how you are going to do this. So the key word here is prioritize. And what I mean by prioritize is choose what tests are you going to do first. And this could be the most painful end-to-end test that you do manually, and it can be the simpler tests that you do just to start with and try to understand if you can work with this framework. So just unite the team, and if you are by yourself, don't feel sad. Just do this and think about it, really sit down and take a look to what you are going to do and what is going to be the first thing that you are going to do. And parallel to this, do documentation. This is very important because the knowledge cannot be only in your mind. You need to share it with the world, with the team, with the company, so that people know what you are testing, to be reassured that the application is stable to go to production, and just for you to have some place where you can rely to understand what you did in the past. Because right now, if you are starting, it is very easy to understand what you are doing, but in 6 months or 1 year from now, I really doubt that you remember what you are thinking when you start the project. So if you have documentation, it will help you to have place to go, to remember what you are thinking in the beginning, to show to other people what are being testing in the application, and it's good practice. So I know that some development people really don't want to take the time to do documentation, but just do it. It is good practice, and you're going to thank me in the end, believe me. And after you have this, after you have the list of test types that you want to choose and that you choose to do, the framework that you choose to work with, the reporter that you think is best for the team to use, and the prioritizations of the tests that you are going to implement, now it's time to schedule a meeting with the management team or with the manager. So have this really structured in a way that when you present this, there is no option for them to say no. So you did all the work, you analyze the product, you search for the frameworks, you plan the work that you are going to do in the next month, 2 months, in the next time. So present this with the certainty that the team and you want to do this and are very sure that this is the best thing for the team and for the product, and be confident about it. This is important to tell you, because I think that sometimes people just think that, oh, this is my opinion, but be really confident that this is the best thing to do and you are going to do this. And share that confidence with the management team and be reassured that they will not cut your legs. They will be really, really happy to let you do this. So have lots of fun working with this, programming or not programming. And if you have any doubts, just go for it. Thank you so much and see you next time. Bye.
So many thanks to Leah for such a fantastic talk. Remember to join spatial.chat for the Q&A session with Leah. Feel free to ask questions there. We'll have next talk with Arten. And Cecilia, back to you.
Thanks, Valmer. So up next, we have Artem speaking, but before then, don't forget to check out the special offers from our sponsors. You can go to TestJS Summit/perks to find out more. All right, so please meet Artem, our next speaker. Artem is going to be speaking on dissecting complexity in tests. He is the creator of Mock Service Worker, and he loves teaching people that testing can be useful and fun. Definitely something that we believe in here at TestJS Summit. All right, Artem, the stage is yours.
Hello everyone, my name is Artem and I'm a software engineer at Kotzenbox. Today I would like to speak about complexity in tests. But before I begin, allow me to ask you a simple question. Have you ever felt like writing a test for a feature would require more time and effort than the feature itself? Well, like me, you have. Then the chances are you were dealing with one or maybe multiple ways how complexity may manifest in your code base. But you shouldn't feel bad about it, because no matter how great engineers we are and what incredible code we write, complexity is destined to happen. It's fine. Complexity in itself is not the issue. It's how we choose to deal or not to deal with how it manifests what matters. And while complexity can be a broad topic, for the sake of today's talk, I would like to reference to it as a quality or state of being hard to write, understand, or maintain a test. And when it comes to complexity in tests, it can be divided into two main groups. It's the complexity that comes from the system that we're testing, and this can be really any code, a React component, a backend route handler, or a JavaScript library. And complexity that comes from the tests that we're writing. So let's start from the system. And one of the most common ways how people stumble upon complexity coming from the code that they test is that they don't know what to test. I'm pretty sure you've been in this situation. You open an existing file and it seems to be doing everything possible in the universe and you have zero idea how to even approach testing that. Well, there's actually a great rule you can follow in these situations. It is whenever you're in doubt, start by testing the most critical user-facing paths. So if you're building an e-commerce product, well, starting your test strategy from a logging flow or a checkout flow makes most sense. And if you're developing internal tooling or libraries, then start from those happy paths that users expect, and that should set you on the right track. And then when you know what to test, the next biggest problem, the next challenge is how to test that. And I think very often when we feel struggle with how to approach testing, it's because we miss some sort of testing philosophy. And one of the most useful approaches that I've adopted over the years is testing like the user. What it means is that whenever you write a test, try to model it from the user's perspective. So your test actions that you perform would emulate the actions that that user would do with your software. And your assertions that you write actually reflect user expectations as the result to their actions. And then another thing that helps tremendously is when you invest enough into testing setup. And I feel this is very often overlooked, and it's a shame because the testing setup is perhaps one of the most important phases that deals with the complexity. Because the point of this phase is to create this universe, this box, where any test can run, where any test that you want to write can actually execute without problems. And I'm going to talk about testing setup a little bit later into the talk. Okay, so when you know what to test and how to test, you may be stumbling into another problem, and that is writing too many tests. And it may sound like a good thing at first, but it's not really, because each test should have a purpose, and we often seem to forget the purpose behind testing in general. And we write tests not to gain code coverage or to have the CI passing, although we want that. We actually write tests for a single reason. And that is, we write tests to describe intention behind the system. Think about it. Whenever you write a piece of logic in your code, you have some sort of intention. You want that code to do something. But unless you have an automated test to validate that intention, you have no proof that your code works as expected. So the next time you approach a test, ask yourself a question: is what I'm testing actually related to the intention behind this code? Because if it's not, chances are you can drop this test and still lose no value in your testing setup. And then the other thing is that, well, real world is quite more complex than that. And sometimes there are objectively complex systems, right? Or are there? Because one thing I love about testing is that a testability of the system is an implicit test in itself. Now, what this means is that when you have poorly designed, poorly architectured systems, as a consequence, they're going to be really hard to test. And the opposite stands true also. Let me give you a few examples of how this manifests. So in this getUser function, we fetch user from the database, but we also fetch all the posts for the user. And this feels that it doesn't belong here, because now to properly test this function, we need to also mock everything related to posts, and this is a stretch. What maybe the proper approach here would be to split this one function into two, and test them all in isolation, which would be much easier. And another example is related to dependencies that our code introduces. Like this shopping cart controller, you can see that in the constructor, we're creating a new database connection. Well, maybe that's not a good idea, because to test this controller now, we need to implicitly mock this database constructor somehow. Why not just pass it as an argument to the constructor, do dependency injection, and thus allow us to test, for example, against the test database during testing, which would make this whole experience much easier. But my point here is not to give you some practical pieces of advice on how to write better code. I'm pretty sure you know that already. I'm just trying to encourage you to stick to those best practices, because the better code you write, the better tests are going to be for that code. So best practices matter. So to summarize, how do we tackle complexity that comes from the system? Well, first of all, we establish a clear testing strategy. And when we're in doubt, we're testing the most critical user-facing paths. Then we adopt some philosophy, for example, like testing like the user, which really helps us model our tests easier, and we know how to approach any logic that we test. We need to invest into the testing setup, because it's one of the most important parts of the setup that allows us to write any test we need. And of course, we can use the testability as sort of an implicit check to help us see that the code that we're writing still stands true to the intention that we have for that code. Okay, now let's speak about complexity in tests. And one thing that often comes to mind is that we introduce that complexity ourselves. For example, when choosing the wrong testing environment. Imagine if you're testing a Next.js page, but you decided to do it in GS DOM. Well, you're going to have a really bad time, because that environment is not designed to test full pages. The same is true if you decide to test a single JavaScript function and you spawn an entire Chromium instance to do that. Sure, that would work, but is that really the right approach? And to solve this is really straightforward. Choose the proper testing environment. And it is often the environment in which your code is destined to be run. So if it's a Next.js page, just launch it in a browser and automate tests there. If it's a simple JavaScript function, perhaps a Node.js-based testing framework would be enough to test it efficiently. Okay, now the other thing, and it's perhaps one of the most crucial things in the whole testing section, is the testing setup and how very often we lack it. I mentioned it briefly before, so let's go into more detail here. And the idea behind the testing setup is to create this environment where any test that you need can run. And this is why this phase should do the most heavy lifting in terms of complexity mitigation. So this is where you do HTTP request mocking, where you create test databases or mock connection to databases, and tackle any sort of side effects that your code commonly introduces. And this is why utilizing setup and action phases as well is crucial. And let me show you how, using an example. So when it comes to mitigating complexity, you really want to do the most of it in the setup phase, like I've mentioned. One of the reasons why is because you do it once and you have this environment and you can run any test in it, which is great. But then even after that, you're still going to have some occasional complexity coming from the test actions that you perform, because there's very often some logic, some abstractions that we do in testing, and you can just move them into helper functions and utilities, and thus reduce the visual clutter, but also complexity of tests overall. And you absolutely never ever want to tackle complexity on the assertions level. And I'm going to show you an example why just in a minute. But most importantly, keep it simple. I once had a pleasure of reviewing a pull request that had a goal to improve the testing setup. And while it was great, I'm ashamed to admit that it took me around 25-30 minutes just to understand what a test setup was doing for a single test. So half an hour, but I wasn't anywhere near understanding what the test does, what the code does behind the test. No, just the setup. And it's really important to keep this in mind when tackling complexity. You shouldn't really respond to complexity with more complexity because math still stands and 1 + 1 can equal 2 complexities. Instead, you want to respond to complexity with granularity. So single-purpose small functions that in total contribute to creating the testing setup that you need. Okay, now let's talk about assertions. I think in the light of reducing complexity and repetitiveness, we tend to overdo it sometimes. And here's an example for you. So this is an assertion from a test block. And whenever I read any test, I'm actually starting from this expect lines because they're the most useful to me. So in this test, we expect a file content to equal a string. This is pretty straightforward, but it's not what the test does. Because if we look above this expect line, we see that there's a for loop. So we're actually testing every file from a follower to have the same content. And even that is not enough because there's another loop above, and we're actually testing all the followers and all their files to equal a specific string. Just notice how many things we need to compute in our head just to understand what the single expect line does. So it feels like we're abstracting complexity, but we're actually just adding more complexity to our minds to tackle through. So I believe that a test block is the worst place to get smart. And let me show you how we can redo this expect line to be much better. So this is the same assertion from before, but now it reads in a single line. We expect that all file contents would equal a string. That's all. There's no additional context attached. And if we need to find out where the file contents are coming from, we can just jump to the line that gets them, and we can see, hey, it uses a utility function, so we abstract that logic away, because in actuality, this test doesn't concern itself with how to extract those contents. It only concerns itself about the equality. And then another point relates to test structure. And let me tell you a story. I was once working on a really big project and it had a lot of tests. And one of the test suites was 4,000 lines of code long. And as it often happens, something went wrong, there was an issue, and CI started to fail. So I jumped into this and I tried to figure out what's happening. And I saw that this test was failing, this assertion was failing. And I spent a couple of minutes, then half an hour, then an hour, and it just didn't make sense to me because, well, it was like saying I expect 1 to equal 1, and it was false. It didn't make sense. But then I finally figured out that a couple of thousand lines above that failing assertion, there was a before all block that was completely mutating the result of the whole system. And I wasn't very happy about it. But it told me an important rule, is that we should try writing tests that would still make sense at 3 a.m. Because imagine it's middle of the night and pager duty wakes you up and production is failing. So you open your laptop and the first thing you do, you go to the test, which is hopefully there, and you try to figure out what's failing and what is the intention, how it's supposed to work. But if you have a lot of smart assertions to compute in your head, if you had a complicated testing setup, if you have this mutable system result, you're gonna have a really hard time debugging all that. So you're gonna end up pissed, you're gonna slam your laptop and you're gonna go to bed, and this is gonna be a horrible experience that you could have prevented. And you can prevent it by keeping your tests flat. And here's an example for you. This is a typical test. So we have a describe block that wraps the whole feature. It prepares some environment before all tests. Then it has a sub feature, for example, and it has its own setup. And then finally the test. Even at this simple example, notice how many things we need to keep in mind just to understand what this single test needs. So why not just put it into the test itself and drop the describe blocks altogether? And I hear you, it's going to be pretty confusing and repetitive at first, but in time you will grow to love this because the benefits this gives are just incredible. It's declarative, it's explicit, and you understand what each test needs from the test, from reading the test. And then, of course, you can create and reuse test utilities to abstract commonly used logic. For example, if in this test we fill in a signing form, and we do this very often to test the signing feature, well, why not abstract it into a helper utility and call it sign in? And notice how immediately this reads much better. It reads like the intention. We want to sign in with these credentials. It doesn't matter what are the form selectors, what are the IDs and classes, it doesn't matter. The intention is to sign in and then do some expectations. And of course, one of the most overlooked approaches is that you can split tests. You don't have to stuff all the tests in a single test file. So if you have a complicated feature like the sign-in, and it has different providers like email and GitHub, well, put them into separate test files. And it's going to give you great readability and discoverability for the price of zero. And then when you need to add more logic and more tests, just add new test files, and that's it. The same stands true when deleting features, because just as good code, good test is the one you can easily delete. It's the test that doesn't introduce a lot of implicit dependencies and all sort of magic in the setup, which makes it really hard to remove. So to summarize, tackling complexity in tests, it's very important to use the test phases properly and to do the most heavy lifting on the setup phase, and then of course reduce repetition in action phase. It's really crucial to express intentions using helper functions like the signing function I just showed you to help your test read like specification instead of a bunch of implementation details. It's really good to keep test structure flat, so perhaps putting everything a single test needs in a single test block, and of course use simple explicit assertions so you don't have to compute a lot of things in your head to understand what the test does. And when it comes to complex features, well, you can also split them on the file system level and gain this great discoverability and great maintenance over time as your product develops. Of course, there's much more to complexity, but that's all I have for today. So make sure to follow me on Twitter if you like this talk and share with me some of your experiences with how you dealt with complexity in tests in the past. I hope you enjoy this and have a great day.
Thank you, Artem, for that amazing talk. Feel free to ask Artem questions on Discord in Q&A. Go to Q&A testing localhost track channel on the TestJS Summit 2022 section in Discord to ask your questions there. Up next, we have our gold sponsor, StackHawk. StackHawk makes it easy to automate application and API security testing in your CI/CD pipeline. Find and fix security bugs before they hit production with stackhawk.com. Up next, we have our speaker, Shivai Lamba. Shivai is talking on machine learning-based unit testing in JavaScript. Shivai is a software developer specializing in DevOps, machine learning, and full stack development. He is an open source enthusiast and has been part of various Google programs as a mentor and has also been an MLH fellow. He's given talks at various conferences like GitHub Satellite, Voice Global, TensorFlow.js Show and Tell, and now TestJS Summit. Shivai, the stage is yours.
Hello everyone, welcome to my talk at TestJS Summit 2022. My talk title is Machine Learning Based Unit Testing in JavaScript. A very quick introduction about myself. I'm Shivai Lamba, a TensorFlow.js working group member and a Google Summer of Code mentor at TensorFlow. So first question that of course will come to our mind is why machine learning and software testing? Now, if you want to understand more about how machine learning is actually used in software testing, I'll recommend you to go and watch my last year's video at TestJS Summit 2021, where I presented a talk at predictive testing in JavaScript, the help of machine learning, and how you can basically use machine learning for being able to not just predict what type of test cases should be put, but also how you can make your test coverage and basically make better test cases with the help of machine learning. So in case you're interested in that, I'll definitely recommend you to check this out. But of course, today's session is all about unit testing and how you can basically include machine learning in unit testing. So in case you're not aware of what unit testing is all about, so basically unit test is a way of testing the smallest pieces of code, and these could be, let's say, a function, a subroutine, or a method that might be defined in a programming language. And of course, we have different types of testing techniques like integration testing, but unit testing is by far the smallest testing procedure that works on a single function or a single method. And that makes unit testing also a really important part of your entire test driven cycle, because it's very important to ensure that we are able to test each and every smallest functionality of a software. Because if you have a very large code base, even a small function that might not work that might not work properly might end up causing some unknown errors inside of your entire code base. So it's really important, and unit test cases form a very important aspect of the entire test driven programming for any organization where testing is being conducted. So but one of the drawbacks that it sort of we can discuss about unit testing is that it's a very manual process. So whenever software testers are writing unit test cases for functions, now let's say if you have a very large code base, you could have multitude of different functions that you're writing. So if you end up writing unit test cases for each one of them, then it can take a lot of time to just write, and it's a lot of manual work. So over the past few years, a lot of effort is going into automating the unit test case procedures. And again, the main idea is that with the help of the automation in unit testing, we are able to actually capable of reducing the boilerplate code that is required for unit test cases. And we are also able to suggest and create useful a combination of test data that can be provided to software testers to be used as part of their unit testing capabilities. And this overall helps us to actually improve our code coverage as well, and helps us to write custom test cases that might have been missed out by the software developers. And that's where the advancements in machine learning and AI is basically helping us to be able to do this automation in unit test casing, and helping us to improve the overall test coverage that was more difficult to do manually if there is manual test cases being written by humans. So today we are going to be taking a look at a few of the tools that are available today to software developers to be able to do automation in unit testing with the help of and specifically within either JavaScript or TypeScript. Now, the first tool that we're going to be taking a look at is the Ponycode tool. So Ponycode is an AI-powered extension that helps to basically generate unit test cases for you. And based on the functions that you write inside of your code base, it will recommend certain test cases for you and automatically generate the unit test file for you. And this essentially is also done with the help of a very intuitive graphic interface. So you can basically get either you can either use the VS Code extension, or you can also use the CLI that is provided by Ponycode that can be used for, let's say, writing unit test cases or automating the unit test cases for an entire directory. And you can also use the CLI tool, as mentioned, like the CLI tool as well. And you can also use GitHub Actions provided by Ponycode that allow you to basically combine automation test generation during your CI/CD platform. So let's basically take a look at the product demo. And of course, if you want to explore deeper into how to get started Ponycode, I'll recommend you to go ahead and take a look at docs.ponycode.com. But for this demo, we'll just quickly now move on to VS Code. And first, let's basically go to this particular link for the docs. So as you can see, you can either install the Ponycode VS Code extension or the CLI, or you can also use it as a GitHub action. And it's free to use for individual developers. So if you click on the VS Code extension and install it inside of your VS Code, it will look something like this. So if you're basically using, you can see that it will basically show up over here as this Ponycode icon inside of your VS Code. And you can take a look at some of the things such as the getting started page. And this basically shows you how to very quickly get started and generate unit test cases inside of your application. So the one that we are going to be using is the Ponycode VS Code extension. So in this case, in my file directory, I have created a Ponycode folder. And over here, what I've done is I've just created a simple index.js file. And I have just created a simple function for adding two numbers. So first, let's take a look how this will basically function, right? So as soon as you basically write any function, Ponycode will automatically be able to detect the function that you have written, like a JavaScript function. And over here, you can directly see that we get this UI graphical user interface where you can see that we can click on this Ponicode unit test, which will basically generate a UI platform. And you can see that it basically comes up with some suggestions for unit test cases that you can basically write. So over here, you can see that these are the suggestions being provided by Ponicode in order for you to, let's say, increase your test coverage. So let's say that I want to probably take this example of A and B. So basically, since it's a add two numbers function, we are having two variables, and here it takes these two values. So what I can very easily do is that either I can test this particular function, and as you can see that, it basically just generates the response, and I can actually click on the plus sign if I want to basically add this particular specific test case inside of my Ponicode. And what it immediately does is that now we have a new folder in place, and this folder is the Ponicode folder. So if I go and explore this Ponicode folder, you can see that it is the index.ts.js file. So this is an automatically created test generation file that has been created by Ponicode. So if we basically take a look at what it includes, right? So you can see that it has, first of all, what it has done is that it has imported our index.js file, and now it has basically described a function index.addTwoNumbers, because that's a function that we have from our index.js file that we have created, and we have generated a test over here where it is getting to these two values. Now, let's say if we want to add some additional test cases, we can very easily just click on the UI, on the Ponicode UI, and add that. So that will basically automatically get added inside of your test.js function. As you can see that we have another function that we have added, another test case that we have added. So this way you can either remove or delete these test cases, and automatically the unit test that is being generated for you will be changed. Now let's also take an example for an async function. So let's define an async function, right? Because Ponicode actually works with both static functions and async functions as well. So let's say we define an async function as, let's say, get first name, and let's say it is for a person. And over here, we'll go ahead and define this. So let's say that what we do is we return basically person dot name. So if we actually click on the Ponicode unit test generation, it will automatically be able to actually understand that this is basically a async await based function. And you can see, right, that by giving a proper function name, it is very intelligently able to also understand that what we are using is basically names. So it basically gives suggestions for the names as name, let's say as peer dot over here, and you can take some examples. So if I again click on this plus icon, we should again see this inside of our function. So as you can see that it basically describes the same the function, and you can see that it automatically detects that it's an async function. So it automatically provides us with an async await inside of the test case that we have basically written. So you can see that it very intelligently is able to understand what functions that you're writing, and automatically suggest some test cases for you. And if you add those test cases, it will generate the file, and it will automatically generate the unit test case for you. So you don't have to write it on your own. So this is really great if you are, let's say, just getting started with software testing, with unit testing, right? And or let's say if you are willing to actually increase your test coverage, so you can add as many number of test cases that you want with the help of these suggestions. So that is why the Ponicode toolkit is very very easy to use and very strong, and it's supported across multiple languages as well, JavaScript, TypeScript, and even Python, Java. So you can also use for other languages as well if you want. So it's as easy to use. And of course, if you want to be for it to be part of your CI/CD, then you can basically include it as part of your CI/CD workflow as well. Now, so that is all about a very quick introduction about how basically Ponicode works. So in case you want to install it, you can very easily just go ahead and install the VS Code extension or the CLI platform. Now we'll basically move ahead with our next one. So the next tool that we'll take a look at is the GitHub Copilot. Now, what exactly is GitHub Copilot? It's basically an AI pair programmer that was created using the OpenAI Codex. what it essentially does is that it basically looks out for all different type of public code bases, including all the open source repositories on GitHub. And the OpenAI Codex model basically inputs all of this entire code that is provided, and it is able to, of course, with the help of AI, it is able to recommend you functions whenever you're writing a code. So it kind of acts as an code auto completion, but of course as an intelligent code auto completion, and it can suggest you complete lines of code or entire functions as well by just defining these function names. And today we'll see that how we can basically use GitHub Copilot in the scenario of actually let's say autofilling the VS, autofilling your entire unit cases. Now, of course, in comparison to the Pony code, it cannot just suggest or it does not provide you a UI specifically, because the GitHub Copilot is not like a dedicated software testing automation tool. It is essentially an auto completion code. But what GitHub Copilot can do is that it can understand the context of your entire directory or of your code that you're writing, and then appropriately autofill your code that you as you write. So let's say if you're writing some unit test cases manually, it can at least give you suggestions for auto completion of your unit test cases that you're writing. And we'll take a look at a quick demonstration of how that basically works. So let's take a look at basically the demo for the GitHub Copilot. So what we'll do is we'll basically go ahead and take a look at, so I've basically, within my VS Code, I have created another, another directory over here, which is with the name of Copilot. And over here, I have an index.js function, and I'll just close out all the other ones that are not required. And we'll just go ahead and save it. Let's just close all of this. Yeah. So this is the very simple function that I've created over here. I have an English code and a Spanish code. And then what I've done is we have a simple function about get about us link. So basically based on which particular which particular code that we provide, whether it is in English or it is in Spanish, so it will return the about us page based on that specific language. So what we'll go ahead and do is that we'll basically create a unit test case for this. Now, of course, as a dev dependency, something to keep in mind is that we are going to be installing we are going to be using Jest as our dev dependency. So over here you can see that what we are going to be using is that we are basically using Jest. So in case you are also willing to use, so you can very easily just do yarn add Jest, and that will basically add the Jest npm package for you. So just install Jest is basically used for JavaScript testing. So you can install the specific Jest based npm package. And I'll quickly navigate now to the Copilot folder. So let me do that. Now we are inside of Copilot. So what we'll do is that, of course, with Jest, the way you write test cases is that you create a in basically a dot test.js file. In this case, whatever is your main file, you'll create a corresponding file over there. So this is where we'll basically write a test case. Now, in order to basically get started with GitHub Copilot, we can visit the GitHub Copilot, and this is basically the GitHub Copilot. So again, how it basically works is that you can install it as an extension on your VS Code. So of course, right now it is paid, but let's say if you are an open source maintainer, then you can basically get GitHub Copilot for free. So if you're an open source maintainer or contributor, you can get it for free as well. Or if you're a student as well, so you can definitely get it for free. So again, how it basically looks is that once you have successfully installed it on your GitHub, then you can, on your VS Code, you will find the Copilot icon over here. So you can see that right now it is enabled for me, and you can also enable it again in a few clicks. You'll be able to enable it and use it. So now what I'll go ahead and do is that as you'll see that as you type something, it will auto suggest code for you. So let's say that I write over here a comment that, let's say, write unit test case. So it will basically understand the context and you can see like it is already providing something like a suggestion for the function auto to numbers. But of course, what we'll just do it and we'll type, let's say for we can say like, let's say write a unit test case for index.js file, right? So we are basically going ahead and going to be using that. So let's go ahead and actually start writing our function. So as you can see, like, it automatically knows the path. So let's take this as like a suggestion from the GitHub Copilot. And now let's go ahead and write our actual function. So first what we'll do is that we'll first get, let's say, we'll define a variable get about us link. And this will basically require from our index function that we have created. So over here, we can get it from the index, right? So we'll get it from our index. Now let's define our test. So in this case, the test that we'll define. So let's define our test over here. Let's say that we define it as in this case, let me write. Okay, so let's basically define our test as returns about us in English language, let's say, in English language, right? So as you can see, like as we are typing, it is automatically providing us suggestions for code. So in this case, I'll just complete this code over here, and now we'll basically write our code. So we'll say that we expect, right? So let's define this. And as you can see that it automatically suggests us the code that we are basically using the get about us link, and we are going to be using the English function, and it should be about us. So let's just complete this. And let's use this, and let's go ahead and save this. So this this particular function, and use jest. So as you can see, okay, so it probably failed for a second. Let's just go ahead and ensure that it works over here. So we'll quickly take a look at the index.js file, and it should be about us. So let's actually look at the test so basically the jest has generated the test. Let's just try to see if we are able to run this. So we'll use jest. And as you can see that it basically passes, right? So that's the idea that, with the help of the GitHub Copilot, although it does not provide you an entire UI, something very similar to the Pony code, but it still is intelligent enough to understand the context of your entire directory and then provide you auto suggestions for code as you write. So you can basically very easily write unit test cases with the help of the auto suggestions that are provided by the GitHub Copilot. So of course, these were a couple of the different tools that we basically took a look at. Now, there are a lot of other different tools as well that today are being created that are available for other languages as well. But these were a couple of the demonstrations that I wanted to showcase for JavaScript. So in order to summarize, right? So whether you want to basically get started with unit test cases, or if you want to increase your entire code coverage inside of your test-driven programming, tools like Pony Code and GitHub Copilot allow you to basically do that and allow you to decrease that manual effort that is required to be able to generate so many test cases, right? And it also helps you to think about those kind of test cases that you might have probably not covered or might have forgotten to add. And that's why these tools are very powerful for helping improve the overall code coverage and helping achieve the dream of achieving 100% code coverage. And especially in this area of today's generation of test-driven programming, the adoption of these tools is going to be improving a lot. And automation of unit testing is definitely on the way ahead. With that, thank you so much for attending my talk. And you can connect with me on my Twitter @hotdevelop and on my GitHub as well. And in case you have any questions, feel free to reach out. And I'll be also hanging out in TestJS Summit. So if you want to connect with me, I'll be more than happy to talk about AI and how AI is revolutionizing software testing. Thank you so much to the entire team. And I hope to see you next year in TestJS Summit 2023.
Thank you so much, Shivai, for that great talk. Remember to join spatial.chat for a Q&A session with Shivai. Feel free to ask your questions there. And just a reminder that our feedback form is open. You can fill it out throughout the whole event. Let us know what talks you like the most at testjssummit.com/feedback. All right, and now we're going to have a break. Stay with us. We have lots of interesting talks up ahead.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to...
Creep while you and me repeat. This bittersweet heat is suffocating.
All right, welcome back from the break. I hope that you enjoyed it, and we are ready to get back to the show. So let the world know that you're watching the conference. Show us how you're watching us and where you're watching from. Tweet it with hashtag TestJS Summit, and we'll be looking out for your tweets. We will also have a raffle of a conference t-shirt at the end, so make sure, again, to tweet with hashtag TestJS Summit to enter. All right, so our next speaker is Kat, talking about testing mail service with Playwright. Kat works as a quality engineer at Zoopla. She tried lots of paths: fine arts, comparative literature, social psychology, and cognitive science studies, before discovering the most enjoyable path so far, which is tech. She solves modern browser testing challenges at work and jigsaws after work. Kat, welcome. The stage is yours.
Hello everyone, my name is Kat Kmiotek. I work as a quality engineer at Zoopla. And thank you for joining my talk today. I will be talking about testing mail service with Playwright. I will show you how easy it is to add email verification or reset password user journey to your end-to-end tests. And honestly, I really like how clever you can go here with Playwright. So let's start. Depending on the application you are working on, you may or you may not communicate with the user by the email. But if you do, you would send them newsletters, order confirmations if you work on an e-commerce website, reset password link if the action is requested by the user, email verification request, and any sorts of receipts or notification they may ask for. And you usually use the third-party providers to handle this mail transportation for you. And those would be Amazon SES, MailChimp, Postmark, and SendGrid, just to name few. And it's a really good idea because we can rely on them to make sure that email is actually delivered. But the problem statement of this talk is what gets delivered to the user. Can they click the link and reset their password? Does verification email actually takes them to the correct domain? If body content of the email actually matches our design system? And of course, if by mistake we don't send any sensitive data or any random data like this is test as a subject of the email. So today I will show you how all those checks can be performed with help of Playwright. So let's start. So to describe the email communication in a production application, you will have application communicating with third-party service, and third-party service will be responsible for delivering emails to the user or user groups. In a test environment, for this demo, instead of sending request to the third-party service, we'll be sending email to fake SMTP service. And then from there we'll be able to access data from Playwright tests. Okay, I just introduced new thing, fake SMTP server, what it is. You can think about it as a container that will be capturing and storing all emails sent by application in a test environment. And for this purpose, you can choose one of many tools available. I listed just few here. Some of them are paid and some of them are open source. It's up to you which one you will use. For this demo, I'm using Mailhawk. All of them usually come with really nice graphical user interface that you can access in your browser. That looks exactly like the mailbox. You can browse emails, you can delete emails, download attachments, or forward emails. It's great for manual verification, what gets sent to the user. And that sort of fake SMTP server, they will also come with great documentation about their API, so with Swagger. Swagger would list all available endpoints on the service with methods that are available and how the payload should look like and what you expect to see as a response of the API call to the server. Here's the screenshot of the example call to the Mailhawk API. So it's a search point I'm querying here. Based on their documentation, I provided query params to get all emails that has been sent to the test user at example.com. And on the right-hand side, you can see how the response looks like. So good, because status is 200. And then you can see how many emails has been sent to this user. So the service endpoint returns 3. Brilliant, because I was just testing a little. And all of them are listed as email objects in an items array, so on line 5. And each individual email object would have ID, from, to, content, and body. And if you will look closer below line 34, well, from line 34, you can see that body is actually HTML body, HTML code. So again, here we can do some assertions as well. We can check if the certain strings are present, if the certain elements are present, let's say button or link, but also verify if right styling has been applied, right? Just to mention, I'm using Thunder client here. So tool similar to the Postman or Insomnia, if you are familiar with them. Okay, so a fake SMTP server comes with some nice features, allowing manual testing. But we'll use the same SMTP server in our Playwright tests. So let's have a look how to translate what I just showed with, let's say, API testing to Playwright tests. Let's start with pseudocoding what we want to do. So first, our test will need to have precondition, and that depends on your application. That could be the action that triggers email verification to be sent. Let's say user creates the account, or user completes the order and order confirmation gets sent, and so on. Because I'm not connecting to any real application here, it was just a script that triggers sending email. Okay, so what we want to focus in a test. We want to do exactly what I did manual with connecting to the SMTP server. So I want to access SMTP server. I want to get most recent email that has been sent to the user. So in a response, there was items array. So I want to get the first element of it. So with index 0. And I want to get HTML body part, because that's where I want to do assertions on. And the great magic feature of Playwright, you can actually use this HTML body to render a new page and do the same assertions as you would do on a regular page in a browser. So you can click verify button link, you can check if certain elements are present, and you can also verify if by clicking the verify button, you will open new tab, and you can do assertion if the new tab, which is also a page, will have expected URL. Okay, so that's a lot of to do. So where to start? I will start with accessing SMTP server from my end-to-end tests. And for this purpose, I will be using fixtures. What fixtures are? So probably in your application, you have Playwright config. Well, in your end-to-end test, you have Playwright config. And you specify base URL value there. And that would be front end of your application client code, the base URL of your all tests. But you can specify also fixtures, so like isolated contexts that will be used in a certain test. So here I'm creating the fixture called email API, and that one will have separate base URL value, extra HTTP headers, and so on. So that fixtures allows you to add maybe different endpoint, test from the same repository, test also backend or other services, like here example, Mailhog. So as you can see, I provide the base URL value, which is running on localhost Mailhog server. I pass authorization as an extra HTTP headers, and I also specify to ignore HTTP errors as true, because I'm trying to connect to localhost. And this API context that is defined on line 11 will be used on all calls made to email API. Okay, and how it looks like actually when you use it. So on line 14, here I can see that, on the left-hand side, you probably don't see this 14. It's 14, line 14. I do exactly the same what I did in the Thunder client when I was manually testing endpoint. So on the API context that I just defined, I do use the get method to query the search endpoint. For the query params, the same as in a Thunder client example. So I query all the emails that has been sent to the test user. And then I return the response. And here, this may look a little bit complex. What is happening here? Here on line 26, I get the first email, so items, index 1, content and body, to get the HTML body of the most recent email that has been sent to the user. What is happening on line 26 might look a little bit confusing. So when I was showing in the Thunder client how the body looks like, HTML body of the email, maybe you noticed that there were appended equals 3D strings in some places. This is because the type of encoding used for email transportation called quoted printable. So here on line 28, I just tidy up the email body from this encoding. Looks complex, but I rely on helpers libraries to do it for me. And then at the end, I just return the HTML body. So now this HTML body can be used to render the page. So here in an email page, page object, I define my custom go-to method that takes as a parameter as actually the HTML code from the email. And on line 13, I instruct Playwright. Every time I would be going to /email URL, I want this root request to be fulfilled with the email body. So then when on line 16, actually I go to this URL, what will be rendered in the browser will be actually email body. And then I will be able to interact with it as I would do with any page. I will be clicking verify button on line 22 and wait until new tab will be open and will return the new tab. Putting it all together, on line 15, but basically that's how the test will look like. So obviously first precondition, but then as I said, I specified a separate fixture. So that's how I imported it to the particular tests, email API on line 15. So then I use the email API to get email body on line 18 for the test user that I use for manual verification as well. And then once I had this HTML body on line, I think it's line 12, I can use this HTML body to render the email page, click the button on this email page, and then assert that the actually URL of this newly opened tab matches TestJS Summit. Okay, that may work, may not, but if I will run the test actually in a debug mode, I can see browser opening and the Playwright inspector opening beside it, so I can step through the test and see that actually works. So what is happening here? That's the actually first page that opens because the API call happens in seconds just before the browser opens. So here we are at the step that I go to /email and the email is actually rendered. And here Playwright attempts to click element button with ID button 1. And once that one is successful, the new tab is open. And as you can see, the URL is exactly the one that we expected to appear here. So when I've seen it for the first time, I was like, whoa, that's amazing. You can actually get HTML from the API call and use this HTML to render the page. Yeah, it's amazing. And going from here, you can think how many other assertions you could do on the actually rendered page. So you can do visual regression tests. So do the screenshot comparison to make sure that nothing has changed in the version of the email that you are sending now, comparing to the baseline image. Here you may say, okay, I sent to the user as a maybe title or I don't know, a header of the email, I render their username or their first name or initials, and that will be different with every test run because you dynamically generate test data. So here with Playwright API, you can actually exclude this area from the comparison. So let's say mask the H1 locator, and that will help you with the testing the email if the data is dynamically generated. You can also, as I mentioned, once we have this email rendered as a page, you can do all sorts of assertions like as you would do on a regular page. So let's say that check that verify button actually has the correct attribute, or if the state is changing when you hover over, and so on, so on. So I hope that I showed how the Playwright can be used for testing email body and what actually gets sent to the user. So I checked that email got delivered to the user. I checked functionality of the button. So you could see that action click has been successful, that the navigation happened to the correct URL. With Playwright, you are also able to do a visual check on the email, on the content body, and obviously all other assertion on the DOM elements, as you would do. Okay, that's end of the talk. I hope that you found it useful, and the links that I just posted here will help you to maybe try and build a similar solution and apply it to your tests. As I mentioned, I was using Mailhawk, so I provided a link to Mailhawk Swagger, Mailhawk Docker image with auth, so you can just run it on locally. More explanation about equal3D, so the quoted printable encoding. A few words about Thunder Client, so my go-to tool for manual API tests, and link to contact with me if you would have any questions. So yeah, I just look forward to hear your questions now. If you want to access the presentation, you can just scan the QR code and that will take you to the slides. Thank you.
Many thanks to Kat for such an amazing talk. Make sure to join spatial.chat for a Q&A session with Kat. Feel free to ask your questions there. Volmer, take it away.
Thanks, Cecilia, and I would like to thank our silver sponsors. Thanks to Stream and Yoast for being with us. And a huge round of virtual applause for our next speaker on the Testing Localhost track, Matt Fellows, on his talk Beyond REST, Contract Testing in the Age of gRPC, Kafka, and GraphQL. Matt is a core contributor to the Packed Contract Testing framework and a principal product manager of the microservices continuous delivery platform Packflow, a smart bear company. Matt self-describes himself as a polyglot who enjoys working at the intersection of technology, humans, and ideas, ideally fully caffeinated. He's passionate about giving back to the community, sharing learnings at local meetups and conferences, and he's the author of the Muxi Chaos Testing tool. Matt, the stage is yours.
Okay, well, thank you everybody for coming to my talk on Beyond REST, contract testing in the age of gRPC, Kafka, and GraphQL. My name is Matt Fellows. I'm a principal product manager at SmartBear. I was a co-founder of Packflow, which joined the SmartBear family back in April this year. And I'm a core maintainer of Pact, which is a consumer-driven contract testing framework, an open source one, and the subject, or the core subject of much of today's talk. Prior to working at Packflow, I was a consultant. I'm a recovering consultant, and I was lucky enough to work at some of Australia's biggest and largest well-known organizations and their distributed systems, and really see them evolve over my career. There have been, of course, a huge amount of technological change since the days where SOAP, which was the predominant technology when I joined the industry over the years. And in my relatively short career, I've worked from that SOA SOAP starting point to REST and microservices, the rise of public cloud and IoT, event sourcing, event streaming, modern data pipelines, and of course, serverless architectures. And I found in many of these situations and contexts that contract testing was still really relevant and would often look to introduce contract testing into places where there was benefit to be had in shifting left, moving faster, and solving those problems that it solves. But of course, during those rollouts, or often, I'll be on the receiving end of some kind of snarky comment, usually from another competing consultancy, of course, that had the following shaped argument. If we just used insert blank technology, then we wouldn't need contract testing. But is it true? Well, today we're going to examine that statement. We're going to ask the question, is REST really the problem? And could we save ourselves the trouble of having to think about contract testing, writing tests, by using a superior technology to API communication? We're going to learn briefly what contract testing is, why it exists, and the problem that it solves. And we're going to look into, to see if history is repeating itself, or if these newer technologies and architectural trends really do solve the problem. Specifically, we're going to look at a few classes of technologies. We're going to look at specifications such as OAS and async API, to a degree GraphQL, and also IDLs and things like protobufs and Avro and Thrift. There are, of course, others, but these are by far the most common alternatives suggested to me by my consultant interlocutors. We'll look at these from a general contract testing lens, but of course we'll use Pact, which is obviously a tool that I work on, as a concrete implementation to help us understand and how it works in practice. And hopefully you'll see that, while Pact has evolved to meet some of these needs, we'll also see that the problem and solution is much more general than any specific technology or language that we discussed today. Let's quickly talk about, or understand why contract testing exists and the context in which it operates. I think starting with a customer quote is a good way to set the scene, just to help us, feel the problem. This is a quote from a Packflow prospect reaching out for some help, and for argument's sake, and to protect the innocent, let's call him Bill. And Bill is a leader of a testing organization for over 40 teams in a very large banking institution. And you can see here he's basically describing working in this big environment with a highly volatile set of testing environments, which makes it challenging. And he's trying to work out how he can use contract testing to test all the things he's got. He's got RESTful services, GraphQL, Kafka, third-party systems, all these things, right? And what you can take away from this is he works in this chaotic environment. It's complex. And he's looking for ways to bring some process and control to that situation. Now, if it sounds anything at all like your company or architecture, you're not alone. Research from SmartBear's State of Quality, as well as Postman's API report, really back this up. And we can see that, for one, internal microservices are becoming a massive focus for teams. You can see here that 61% say they're going to see the most growth from microservices, but actually behind the scenes, you'll read that there's actually internal services about making data available internally to other teams to create more value, which is really interesting. But you can see that also most companies operate in a multi-protocol environment, 81% or so, and almost 60% have 3 or more protocols. Now, of course, while microservices aren't new and many lessons have been learned, there's these issues we're starting to see, really a decade on, that we're still emerging from this new way of doing things. And in the report, or both these reports, we can see that 50% of people stated that experience or skills were a barrier to getting microservices going, and 35% stated the complexity of systems, this is the second issue, is becoming the problem. And the obstacles are around the speed of delivery, or the expected speed of delivery, versus the time to actually test and build stuff, is really at odds with one another. And what I found most interesting of all was that mature organizations are ones feeling the pain. And so you think, why, this is a bit counterintuitive. If they're mature, they've probably got these practices and technology and whatnot to deal with it. But I actually think the reasons are well understood. The first reason, or one of those reasons, is how we test microservices today. Most companies rely on testing their distributed systems using a form of integration testing called end-to-end integrated tests. This involves basically taking all your applications and deploying them all into one big shared environment and then running a battery of tests against the whole system, so all the layers of your system, right? And then if that works, you can then deploy. Now, this might give you a high degree of confidence. They do, if they pass, they do tend to be quite slow, and they also tend to be very flaky, and they tend to be very hard to debug. And because of all this, they give you feedback much further down the life cycle, right? Because you've had to deploy them before you can get that feedback. It also means they're very difficult to deploy. You probably can't deploy things independently, and you probably have a distributed monolith rather than a nice coherent set of cooperative components, working toward a single end in mind. This creates a problem when you start to scale the size of your ecosystem, both people and software. As you do this, as you add new components and people into the system, you see this non-linear response to things like the cost, complexity, time, or number of environments, build time, the costs associated with change, and developer idle time. But if you look really carefully, you'll notice that you only really start to feel the pain a bit further down. That inflection point is not there at the start. So you sort of come into the system thinking it's easy to use, but then as you scale, you eventually hit this tipping point where it becomes real painful. And so no wonder Bill is having a bad time. This is kind of explaining what is going on there. Okay, so what's the solution? Well, one of the solutions is using things like contract testing. Contract testing can help by reducing a lot of the end-to-end tests and replacing them with a way of testing your API communications, which is often what end-to-end testing aims to do. Contract testing is a technique to ensure that two systems are able to communicate. And we look at those integration points, and we do it by mocking out the dependencies. So if you're an API consumer, you mock out the provider and you replay those mocks against it later on in real life against the real provider. And if those mocks have been validated, we're feeling confident that these two systems are able to communicate. And the benefit of this way of working is that it's much simpler to understand. You're just testing a single integration point at a time. You don't need dedicated test environments. You can run it on your dev machine. Because of this, you get fast and reliable feedback that's easy to debug. These tests scale linearly, and we can deploy the services independently. And of course, we can actually track this over time, which gives us this ability to evolve them. So we talked about this at the previous TestJS Summit. Go back and watch that video if you want the rest of the detail of that talk. Okay, so hopefully we've got a bit of a grasp of the problem we're trying to deal with and how contract testing might be able to help with that. Let's now return back to the original hand-waving argument from my consultant interlocutor and ask the question, is REST really the problem? And could we save ourselves all the trouble by using something else? Let's start with OpenAPI and its counterpart, JSON Schema. But you can also think about this as applying to things like Async API and SOAP and other specifications. To an extent, GraphQL comes into this mix as well. We don't have time to talk about GraphQL specifically today. So how does it aim to solve the problem? Well, the first thing is that specifications contain all the bits needed for humans and computers to communicate what an API can do. And it uses things like JSON Schema to tell us what the shape of the incoming data is and what the response shape should look like or what that can be as well. And then we can generate API clients and servers from that OAS. So we know we're not going to have breaking changes, right? So if we can generate a client code from the OAS, are we not always guaranteed to have a working system? Well, of course, the answer is no, otherwise we wouldn't be here. And if you're old enough to remember SOAP, you'll remember that we had all these same features too. A clear specification, a clear schema, and client generation and schema and service generations, but it didn't solve the problem. And REST obviously has some better redundancy principles built into the design of it, Postel's law and extensibility, but it really isn't enough actually. And if you're looking here, if you look at this quote, this is from the JSON Schema website. It basically says if you're going to do this kind of testing with JSON Schema to validate your requests, you're going to need two types of validations. One is a structural tool, the schema level, which is what JSON Schema can do, and one at the semantic level. And that needs to be done in code probably. So JSON Schema still can't do that. It even tells you that. So the aphorism that an API is not incompatible with a spec starts to sum up how I think about and how we think about open APIs. What I mean by that is schemas are actually abstract. And so it's very difficult to say that an API actually does implement a spec because a spec is actually abstract and not exactly that clear. Examples. So optional and nullable fields. In sufficiently advanced OpenAPI documents, you'll see the use of optional and nullable fields, but you won't know in what situations those fields will or will not be present. So in some cases, a lot of those fields turned out to be optional, and so now it's really difficult to actually understand what data will be available at what point in time. But certain consumers may need that information. Combine this with polymorphic endpoints. So these are endpoints that can accept different shaped inputs and different shaped outputs. It now becomes very difficult to say for every single resource in your document which input is going to correspond to which output and under what conditions. In the case of SOAP, we actually had Schematron to help us with this. It had this extra layer of protection you could put over the top of it, but it needed XSLT to do that, which used functions to do it. Of course, we lose sight of the API surface area as well. So if we're using client-generated SDKs, well, we don't know what our consumers are doing, so we have to assume they're using the entire interface, which means we need a different mechanism for evolution. The standard one here is going to be versioning, which we'll touch on in a second. And lastly, but not leastly, client SDKs can be modified and used in unexpected ways. So I was talking to one of our solution engineers in Europe who works with some of the world's largest Swagger and Swagger Hub customers, and he mentioned that basically 90% of all the customers who use CodeGen will actually modify the generated code when the OS changes after that initial generation. So that opportunity for drift is definitely still present. Of course, let's briefly touch about versioning. Versioning is the most common practice here, but it is painful. We don't want to do it if we can avoid it. Teams need to build another version of the software, maintain it, test it, release it. And now we've got multiple versions we need to maintain. So now we've got more code to maintain. Of course, the cost of maintaining code is usually much greater over the life cycle than building it. We now, assuming we don't know what our consumers are using, functionality always carries forward through those versions because we have to assume they need it and want it. And then we need to get consumers eventually onto those new versions, which require us, again, to monitor, coordinate, communicate people onto those versions. Really, this is the cost. And if we can avoid this overhead, we should. So let's talk about the second class of issues here. We're going to talk about interface definition languages. So we're talking about things like protobufs, Avro, and Thrift. And I should say out of the gate here that protobufs by far is the most common comment that came up with me, is that we should just use protobufs. We wouldn't need contract testing because it's got schema evolution built into it from the start. In fact, it's so good, you can go forwards and backwards in time. You can use older clients with newer servers and newer clients with older servers, and they can all communicate magically. And of course, it supports CodeGen as well. And so we can create servers and clients from those definitions. So if it's true that that's the case, then why is protobufs and gRPC the #1 requested feature on our open source roadmap? Well, the answer here is that colorless green ideas sleep furiously. Well, what am I saying here? Obviously, this is an absurd statement. It actually comes from a guy named Noam Chomsky, who was writing about this in the 1950s in his dissertation about language. And he was talking about what he's making a point here is about syntax and semantics, that syntactic well-formedness does not mean it's semantically understandable. So, grammar and syntax are different. There's no meaning here. So what we're trying to say is just because we can communicate with one another, we must still need to be able to understand what it is we're saying. So let's take a bit of an example here. Let's say we've got a Kafka queue, a topic where we're posting orders that are being completed onto that topic. And we have a consumer on that topic that's reading all the orders coming in and tallying up the totals just to do a report or something, right? So it's going to find all these orders. Every time one comes through, it looks at the total, reads the total value, and prints it out, or saves it somewhere. Now let's say we need to change that order structure. Maybe we need to split the total into some different values. We need to split it up into GST or tax or what have you, or we need to move it somewhere else in the payload, right? Either way, it's changed. And now we've pushed out this new message. Well, just because the consumer can still read the message doesn't mean it didn't need that total value, right? It still needs the value. Otherwise, it can't do its job. This problem manifests itself even further and gets much more difficult when you combine it with optional fields. In researching this talk, I spoke with a team that worked with gRPC and protobufs in a global payments processing company. And there was this strange bug appearing where merchants were occasionally not receiving payments from the provider. And after careful analysis and debugging, they discovered there was this merchant service that had been changed. The configuration API had a new Boolean field on it for enabling and disabling payments for a merchant. And they'd found there'd been one single client that didn't know about this update. And every time it sent a request to the merchant service, it would inadvertently disable merchant payments because the default field, of course, is going to be false. So you can see how this kind of bug could be particularly nefarious to find and resolve. And it's actually a case where you probably don't want the forwards and backwards compatibility. Maybe a network explosion would be better. And in fact, to make things worse, version 3 of protobufs gets rid of required fields altogether, which feels very much like what happened with SOAP in the old days, where everything was an optional field, and it was just really an incomprehensible API. So coming back to the challenges with protobufs, we talked about semantics and optional fields. We still need to manage breaking changes. So field descriptors and things like this, technically or theoretically, they should be easy to manage, but actually in practice, it's really easy to accidentally refactor your code and change field descriptors. We may need to consider how we manage transport safety in the case of protobufs, which can go over different types of transports. We may want to look at narrowing the types. So IDLs and a lot of these technologies, in fact, don't have really rich type systems. GraphQL is a good example that does. But let's say you want to store a date, a semantic date, or a particular format of a date, or a semver, or these kinds of things. Well, the language won't have those primitives built into it. You need to put that on top of it. That's actually a challenge. It actually could be a problem. And of course, if we use SDKs and whatnot, we're going to lose the visibility, just like before, into real-world client usage. And of course, if we accept these problems, we now need a new way of coordinating changes. All right, so hopefully you've started to see a bit of a theme here. And whilst obviously these technologies do give us some benefits, they don't actually solve this one problem we've been talking about. So let's return to what lessons we can learn from all this and see if we can understand why consumer-driven contract testing is so effective in helping us. The first point I want to make is that your provider contract is not your API. It is just one representation of your API. And in fact, any observable change in the behavior of an API will be deemed breaking by certain consumers. This observation is known as Hiram's law. So while we can't make this law disappear, we can find ways to reduce the ambiguity. And one of those ways is to bring the consumer's perspective into the picture, which is, of course, how contract testing and PACT can help us. We use record and replay to test the representative examples against a real provider. This gives us confidence it's actually going to work because we're testing it. We also get specification by example through this. This is what we're doing. And that reduces ambiguity. We can now see how it's supposed to work. It improves API comprehension. We can actually time travel. We can actually do time travel in that service evolution because we now know pairs of application versions and what contracts are valid between them at any point in time. So we can actually go forwards and backwards in time. We can go and say, does this version of the consumer, can it read messages from this producer, and kind of vice versa? Very cool. We encode those transport concerns in the contract. We can do narrow type matching in the contract. And of course, because we've got all the contracts, we know what all of our consumers are doing. We have the surface area. That gives us a mechanism to evolve without having to do versioning. So I hope you can see that contract testing does provide this generalized data exchange model that works across transports and protocols and content types. Whether you're providing RESTful APIs over HTTP or protobufs, over gRPC or Kafka, or running Average or file system as part of an ETL data pipeline, the problem we're trying to solve is really the same. It's, can we communicate some data between multiple versions of evolving applications? So while PACT doesn't have native support for all of these technologies out of the box, it can be extended by plugins. So you can write a plugin in your choice, language of choice, to support things like transports or protocols or matching rules. And then you can just distribute that out to all the languages that support plugins. So we've added that support to PACT JVM, so Java and Kotlin and whatnot, PACT Go, and we've just released beta support for JS. So you're all the first to know about that. And the first official protobuf plugin we created was protobufs, of course. So here's an example, protobuf or gRPC/protobuf failing, where the provider has not matched the exact content type of the consumer. So what are our takeaways here? Multi-protocol internal microservice adoption is accelerating, and that the lack of standardization for design and test is contributing to the challenges of microservices sprawl. We learned about Hiram's law and the need to reduce ambiguity, and how really our API is not the specification itself, it's just one view of the API. And contract testing is an approach that can help both reduce the complexity of our testing, but also the ambiguity inherent in those API specifications. And lastly, we saw how PACT can wrap all this up into a standardized workflow for testing those API communications across languages, transports, and protocols. So thank you so much for coming to my talk. I really hope that was interesting and you learned something. If you have any questions, do reach out to me on any of the channels below, and enjoy the rest of the conference. Thank you.
All right, thanks, Matt, for an excellent talk. Feel free to leave your questions on Discord in the Q&A testing localhost track channel, and Matt will answer later. You can also see jobs from our sponsors at testjssummit.com/jobs. There are all sorts of engineering and companies like StackHawk, Sauce Labs, and Yoast. Check them out on testjssummit.com/jobs. And a huge round of virtual applause for our next speaker, Philip Voska, on his talk, Unit Testing Angular Application. Philip graduated from Faculty on Electrical Engineering and Computing at the University of Zagreb in 2017, and has started his career at Infineon as a JavaScript engineer. Over the years, Philip gathered knowledge of various front-end topics with focus on Angular, and became an Angular lead engineer. Some more time passed, and Philip started focusing more on soft skills and became a JavaScript team lead at Infineon, while continuing to do Angular development and being involved in architecture level decision-making. Philip, the stage is yours.
Hi everyone, welcome to my talk about unit testing Angular applications. First, just a quick intro about me. So my name is Filip Voska, I am from Croatia and I'm working at Infinum as JavaScript team lead. Throughout my years, one thing that I've learned is that you really want to be writing tests for your code. Nobody writes perfect code and you want some confidence that it's running correctly, that it's doing what it's supposed to do, and that's what you use testing for. So quickly to go over the topics, we'll take a look at what are some of the ways to test front-end applications, what are some specifics to testing Angular applications. Then in third part, we will take a look at some best practices which are not really necessarily related exactly to Angular, but there are also concepts that you can apply in other frameworks. And in the end, we will have an overview of some of the things which you should test, which you shouldn't test, and like what's the next steps, what are some educational resources. Okay, so let's first take a look at what to test. If you go online, you will probably, and you Google testing, you will probably see something related to the testing pyramid, and it's what describes the ratio between unit integration and end-to-end tests. So in let's say the most common version of it, people say that you should have the most amount of unit tests, then a bit less of integration tests, and then even less end-to-end tests. Now there are variations of this where some say that you should have something like this, which is like a testing hourglass, where you should have let's say equal amounts of unit and end-to-end tests, but a little less integration tests. And then you will also find this sort of shape, which is, I don't know, some kind of vase where you can put flowers in, those are all kind of different philosophies, and that's all a topic on its own. We won't go into details about that. We'll just take a look at what matters for Angular. And for front-end applications, you have usually a choice between Jasmine and Jest. Those are two most popular testing frameworks. With Jasmine, you would also use Karma as a test runner. Jest is kind of all-in-one solution. And Angular ships with Jasmine and Karma out of the box, but it's also quite easy to use Jest with it. Then for end-to-end, you have things like Cypress, Selenium, Playwright, and these are all ways to run an automated browser where it's an actual browser running your code and you're simulating user behavior. So I will be focusing on Jasmine today for unit testing. I will not be covering end-to-end or integration tests. Now, integration tests, you can really do them with any of these tools, because the line between end-to-end and integration and unit tests, it's kind of blurry. It depends on what you define as a unit and how many units are involved in a test. So what is a unit in context of Angular? Well, Angular is mostly composed of different classes, and those classes can be like components, directive, pipes, modules, services, etc. And then you also have functions like regular helper functions that you might have. So mostly we are talking about testing classes in Angular and creating instances of those classes. So let's take a look at some of the tooling which Angular gives us that makes testing and creating those instances a bit easier. So this is the component which we will be working on. It's quite simple. For those who are maybe not familiar with Angular, Angular consists of a class component that has inputs and outputs, and these are the ways that the component can communicate with parent component. So parent can pass something via input down to the child, and the child can basically emit an event back to the parent using an output. And in our example, we have a really simple component where you can see in the template on line 4, we render the amount of time that the button has been clicked. And on line 6, we have a button with attached click handler that calls some method. And that method is defined in the class, and it just increments the counter and emits the event to the parent. So this is one of the most basic components that you could have in Angular. So let's take a look at an anatomy of a unit test. And this is really the same in both Jasmine and Jest. There are some other differences between them, but this is really the same, and this is the same in many other languages, I would say, as well. So first you define a test suite. So we are defining a test suite for counter component. That is, we use describe function for that. Then we usually have before each. Before each is a piece of code which will run before each test, each individual test, and here you would set up some state and some initial state. Then between lines 4 and 6, we finally have one individual unit test, and it's using function it. It's a bit weird naming, but it's called like that because the way you're supposed to read this is counter component. It should do something. So that's why the function is called it. Okay, so let's expand a bit on this basic scaffolding for the test by adding in some Angular specific things. So here we have component and fixture. Component and fixture are related. So fixture is something that has some extra methods and helpers that make interaction with the component a bit easier in the tests, and it allows us to query some stuff, as we will see a bit later. And the component is the instance of the component class itself. So we will have references to two of those, and we will be using them quite a lot throughout the tests. And then on lines 11 through 13, we set up a testing module. So Angular components are run inside of a module, both in runtime and in tests. So here we are setting up a testing module inside which the component will be running. Here we define any dependencies that the component might have. Here we're dealing with a really simple component which doesn't have any dependencies, so we just import that component. Then on lines 15 and 16 we create the fixture using create component, and we get the component instance. Line 17 is something quite specific to Angular, where we call detect changes. This is what triggers re-rendering. So in runtime, when the application is running, change detection, which is the process which is in charge of re-rendering when necessary, it is, let's say, automatic, but in tests you have to do it a bit more manually. And now finally, between lines 20 and 22, we have our first unit test for our counter component, and we simply assert that the component is initialized, that the class instance exists. So it's a truthy value, the component. Now let's test some initial state. So we will use our before each method to query the pre-element and to query the button element, and we will store them in some variables in the test suite because we will be using them in multiple places, so it's more reusable. So here we can see that we use fixture debug element query by CSS, and we get the pre-element. We do the similar thing for the button, and for the pre-element we also read the native element of it. Then finally on lines, now we have 3 unit tests, so we check that the we check that the rendered pre-element exists, we check that the rendered button element exists. Those are the first 2 tests, and in the final test we check that the initial state of the counter is set to 1. And that's kind of just the baseline test to see that everything works correctly initially. Now we want to check what gets rendered. It's quite important that you check what actually gets rendered as final HTML, because someone could delete the whole template of the component, and if you were only testing the component state, like checking the values of class properties, all your tests would still pass even if someone deletes the whole template. So that's why it's important to check what gets rendered, and that's why it's important to actually click on elements, etc. We'll see more about that. But yeah, here you remember we queried our pre-element, It's an HTML element, and we just check that the text content is times clicked 1, and that's also like the initial state. This is how it relates to the template that we have. Now let's, just like we want to check what gets rendered, we also want to check what happens when we do user interaction. And now it's important when doing user interaction testing, you shouldn't be calling handler methods on the class directly. What you have to do is you have to trigger the event handlers for similar reasons as why you want to check what gets rendered. Someone could delete your template. If you're just calling the click handler directly, it will still pass. But if you're actually trying to click on the button and the button doesn't exist, the test will fail. Okay, so that's why it's important. So here on line 7 and 8, we assert that the counter is initially 1 and the times clicked 1 is the rendered text. Then we click, and then we check. So the way we click is we trigger event handler programmatically. This relates to the click handler that we attach. And this test passed. Now we check that the counter is 2, but you will see that it seems like I have maybe a typo here. So I check that the component counter is 2, but the test passes, and what is actually rendered is that the text is still times clicked 1. It's not times clicked 2. And this is because, as I've mentioned, change detection, which is the process for re-rendering, it doesn't run automatically in tests like it does in runtime when the application is actually running. This is why you have to call it manually after some user interaction simulation. So if you trigger some user interaction programmatically, you have to call detect changes to re-render. Now the test will fail because times clicked 1 is not what actually gets rendered. What actually gets rendered is times clicked 2. And you can see in the error log, you get like a nice message where it says what was the expected value and what was the actual value. Now we just fix it by updating 1 to 2. So now this test is valid. So two most important things here is you have to kind of know when you have to re-render in tests. It's a bit tedious, but you have to do it. And the second thing is you have to check what gets rendered in order to be fully sure that everything is working correctly. Now, we were writing unit tests for our counter component. But let's say we are now looking at the template of a parent component. So we want to test like how is our parent component using this child component. And this is now a unit test of a parent component where we can get the component instance of the child component. So here you can see we will use a query by CSS TestJS counter, and TestJS counter is the selector of our child component. You can see in the template it's being used like that as an element selector. Then we get the component instance and we check that the counter input is set to 100. So we are basically checking that our template is doing what we are expecting it to do, setting counter to be 100 initially. We can test the other way around. So if our parent component wants to react on counter change event, we can write tests for that as well. So let's say that on counter change, we just console log the new value in the parent component, okay? This $event, it's a special piece of syntax, but this will be the value with which the event is emitted. So in this case, it will be a number that gets emitted on counter change, and that's the value that gets passed to the handler method. So here the test is, the test is expanded a bit more because we are now using spy on. So spy on is something from Jasmine. It's very similar in Jest as well. So you take console log and you spy that it has been called. So on line 5, on line 3 we set up the spy, and on line 5 we expect that it hasn't been called. On line 7 we trigger the event handler to, let's say, emit 101 as 101 as the new counter value. And then we expect the console log has been called once with value 101. So it's important to check how many times something was called beforehand, how many times it was called after, and with which value it was called. And it's all kind of nicely, you usually want to check that something was called once and with some value, and that's why you have this nice method to have been called once with something. And this is how the event relates and how the event handler name relates to between template and the test. Okay, so let's take a look at some of the best practices. Test doubles. So generally, if your application depends on some, let's say, service, and services in Angular are just classes that offer methods, and they are most commonly used for fetching data. And here our user service is fetching, like making an API call and fetching a list of users. However, when you're unit testing, you don't really want to make API calls. And if your component depends on user service, you want to avoid making API calls. So for that purpose, you would create a test double of user service. We usually call it here user testing service, but you could call it something like user service mock, or something like that. And here you define all the same methods that the real service has, but it doesn't make a real API call, but it returns some mock data. And the way, and this is how it's used in some user table component, for example. So Angular uses dependency injection, and this component would inject the user service. But when we are writing tests, we provide user testing service under the user service. So the component still expects that it will get like user service instance, but when the tests are run, then you get the mock version, the test double, the testing version of the service, whatever you want to call it. And you can do pretty much the same thing for a component. So component also has some methods, it has some dependencies. You can create a testing version of the component for which it's important that it has the same selector, but it doesn't have to have the complex template, and it doesn't have to have any implementation logic. It just needs to have all the inputs and outputs. And you do that very similarly. So if your parent component depends on the counter component, you would in the unit test for the parent component, you would import counter testing component. And that way you don't use the real component, you use a mock. And this is what makes it a unit test, not an integration test. So you're not testing both components at the same time. You're not testing the parent component and the counter component at the same time. You're just testing parent component and using a test double version of the counter. Next topic is harnesses. Now I won't go into harnesses into too many details, but they are something that's provided by Angular CDK, and they are you can define a harness for some component, and that harness will have some extra methods which are useful for testing. So in example of material checkbox, there you have a harness which makes it easier to like toggle the checkbox in tests, etc. But yeah, I won't go into too many details. You can also write harnesses for your own components. Now, last topic about best practices is coverage. So coverage is a metric which tells you from when you gather all of your tests, like how much of the code has been covered. And this is, you can get a nice looking report like this. And if you take a look into one specific file, you can see like which parts of the code have been executed, which have not. Generally, this is a good thing, but it's not something that you should really blindly chase, because coverage in Angular doesn't include HTML templates, so you won't get that in the coverage. 100% coverage, of course, doesn't mean you don't have bugs. And depending on the setup, some files might not be even included in the coverage, so you will get actually wrong numbers, and we have some documentation about that. So code coverage, it's often a lie, But that's a number that like project managers like to hear about. Okay, so let me conclude some of these topics. So what you should unit test? You should unit test business logic, services, core UI components, sensitive data handling, helpers, errors and loading states, test if something gets re-rendered correctly, and anything really related to date time handling and time zones, because that's really, really painful to debug. So having good unit tests for those things, that's really nice. But there are also some things which you shouldn't really unit test, and that's like third-party libraries, your implementation details. And now what I mean by this, you shouldn't like test private methods. You shouldn't be calling them directly. You should always test something in a way that it's used. So if you're testing a component, test it, write your unit test as if you were a parent component. Don't go calling private methods. You also shouldn't test like complex interaction between units. That's like integration tests. That's like not for unit tests. Yeah, it's a different kind of test. Complex UI flows are also quite hard to do with unit testing, especially if it's like things like swiping, etc. So that's best left to end-to-end testing. If you have some like really trivial code or some code that is here only temporarily, you won't really get too much benefit from unit tests. That code probably won't break. You want to test things which are like more complex, which could break, and you want to ensure that those don't break. And again, setting up unit tests can sometimes be quite complex. So if the time it takes to set up unit test is like much greater than the feature is like worth, then yeah, maybe consider skipping it and do some other type of testing. Yeah, so here's just like, in the end, I will leave you with this short list of do's and don'ts. Yeah, you can run through this, but yeah, it's really important to write. I think that what I want to stress most here is that you should write tests based on your requirements. So tests in this way will also be a documentation of what your code should be doing. It's also documentation that can be executed to verify that the code is doing what it's supposed to be doing. So I think that's the most important note to take here. Make sure that your requirements are covered by tests. Here are some additional resources that I have. Official Angular documentation for testing is actually quite good. It covers a lot of ground. We also have Infinum handbook regarding Angular testing, and there we have a lot of different test cases, let's say recipes, how you should test something. You can also find some useful courses online for testing. I'll here linked Angular Academy testing course. I'm not in any way related to them. I just think they have good content. And yeah, that's pretty much it. I thank you for your attention. I know this has maybe been a lot, but please you can go back and look at some certain sections and see if there's something that you maybe want to take a second look at. I'll be in the chat to answer any questions. And yeah, thank you. Bye.
Many thanks to Philip for such a great talk. Remember to join spatial.chat for the Q&A session with Philip, and feel free to ask questions there. Cecilia, back to you.
Thanks, Velmer. Up next, we have speaker Oleg talking about delightful integration tests with test containers. Oleg is a developer advocate at Atomic Jar, working on making integration tests with test containers better for everyone in the community. He's a virtual JUG leader, and in 2017 became a Java champion. Oleg, stage is yours.
Hi, you're watching TestJS Summit, and this is delightful integration tests with test containers. Testing is very important. more projects should test applications better. And I hope after this quick session, you're going to learn about how you can do integration tests, which you like using test containers libraries. My name is Alex Shalaev, and I work as a developer relations person at Atomic Jar, a startup created by the test containers Java maintainers originally. And now we have more people from different language ecosystems helping us work on test containers. If you have any questions, you can find me online. I'd be happy to chat about anything test containers or testing related, or just software engineering in general. I think it would be very, very cool. So drop me a line. Testing is super, super important because it lies on the critical path from development to production. If we don't have the good automated test suite, we cannot release things well. We need to have automated tests because we want to make sure that whenever we have something that we potentially want to release, we can go through our pipeline without bottlenecking on any manual process. This is helpful during your normal development practice, development loop, but it's also super helpful in case there are any security issues or supply chain security issues where you update the third-party packages and then you need to release things because they could be security vulnerability fixes. But if you don't have good test suite that you trust, then this is the manual process and you are as good as exposed. But if you do, you can run your automated tests, you can release immediately because you have confidence in your tests. This is very, very important. And lately, the way how we see what types of tests we want to run has been shifted. In the past, we had the testing pyramid and we ran a ton of unit tests and they covered all possible scenarios and we had very good test coverage, and then it still missed some issues. So recently, independent teams have been coming out how they rethinking the testing pyramid and how they put more and more emphasis on integration tests. Thinking about that, it makes a lot of sense. Our applications have become smaller. We are mostly writing, and we are talking about the backend applications here. We are mostly writing microservices that talk to other APIs or talk to various technologies like databases or message brokers or cloud technologies. And the application behavior very much is encoded in the interactions with those third-party systems rather than the business logic within the particular application, how it transforms the data. So it does make sense to have fewer implementation detail tests and use the integration tests, which run your application with the immediate environment, with all the necessary components for your application to run properly as it would run in production, but in your testing setup. That could be the bulk of our test suite. That could be the tests that we trust and rely on. And we still can have end-to-end integrated tests that run in the environment similar to production, where all the systems are spin up at the same time. And when we check the actual workflows as if that would be a production environment, or maybe production data or a similar data like that, but in a much larger environment. So for the test suite that you run everywhere on your machine, on your colleague's machine, in your CI, integration tests hit the sweet spot between the simplicity of the setup and also how many issues with the real world technologies they can catch. That's why they are getting more and more popular. This brings us to test containers. Test containers is libraries in different languages, including the test containers node implementation that works for JavaScript and TypeScript. They integrate with Docker to create ephemeral environments where you can run all the third-party service dependencies that your application requires for testing. You can run the databases, you can run your Kafka, you can run your Elasticsearch, you can run your local stack. If you work with AWS technologies, you can run them in Docker containers, and your application has the full control over the lifecycle of those, and your tests have the full control over the configuration of those. So you can test your application with the real dependencies and know that it works as expected. Test containers has recently been named in the technology ThoughtWorks technology radar. It was something put into the adopt category, which means technically that there should be a strong reason. You should really know what you're doing if you don't want to use test containers. They are allowing, test containers allows you to create a reliable environment with the programmatic creation of those lightweight containers for your dependencies. And it makes your tests more reliable, and it tries to nudge you into doing the right things with your integration tests. And that's why there are more and more projects which are using test containers in various setups and environments. Test containers uses Docker as the environment where it spins up those containers that your application wants to run. And this is great because Docker is almost universally available. It runs on all popular operating systems, and developers understand how Docker works or how to use Docker from the outside. So this is great option for leveraging a runtime to run those dependencies for your application. However, the stock sort of look and feel, the user experience of Docker is not sometimes flexible enough for your integration tests. Docker allows you to, Docker is great because it has all the software in the world that can be runs in Docker. There are registries where you can pull all the technologies that your soul requires. It provides you with the process isolation. It provides you with the ability to configure both the container and the application within the container. To give you the CPU and memory limits, all those good things, but it is a little bit inflexible for the tests specifically, because during the tests, we want to put our application into the specific scenarios where something might go wrong. What will happen when an application works with a database and the data schema is incorrect? Or what will happen if my application doesn't have has a long latency until it reaches Kafka? Or what happens when my Redis key key numbers are close to the integer range and are trying to overflow? All the different scenarios, and they all break the setup in some way. This is the notion of tests. This is what tests should do. They put your application under stress, and then they want to figure out whether it behaves correctly. So with Docker, once you break the environment, it's very, very hard to recreate the environment. And this is where test containers comes in. Test containers gives you the programmatic access to create, manage the lifecycle, and clean up the containers that you want to run. It gives you API to configure both the container, like expose which ports you want to expose from the container if you're working with it through the through network, or which files you want to copy, or whether you want to programmatically follow the logs of the container, and so on. So you can configure everything from your application tests, from your IDE, and you don't need, you can do this any number of times. So tests bring their own environment into the play. And it also integrates with various frameworks and test libraries. For example, there is a module for Jest test containers, which simplifies working with Jest tests and test containers, where you can declaratively specify which containers you want, for example. Test containers Node, as the other test containers implementations, is an open source project. Christian is a true hero of the test containers Node implementation, the main maintainer currently. There is then npm package, which is how you get test containers into your application. And what it does, it uses Docker Oat to talk to the Docker environment. So your Docker environment doesn't need to be any particular Docker implementation. It, of course, runs with Docker Desktop, but it also can run with any other compatible Docker implementation. So, for example, if you're running Minikube, the lightweight Kubernetes cluster, which exposes Docker API, you can use that to run your test container-based tests. Or if you're using a remote Docker, your test container tests can talk to that. And internally at Atomic Jar, we're building the cloud solution where you can get on-demand VM and run your test containers tests against that. So it's a very, very flexible setup, and it works really well. One thing that is very important here is that test containers takes care of the cleanup of the containers. We know that for reliable integration tests, you need to have repeatable environment, and for that, you want always to clean up after the run. That means if your tests pass, we clean up the containers and remove them. If your tests fail, we clean up the containers and remove them. If your machine runs with a remote Docker environment and your machine crashes and like internet blows up, we still will clean up the containers on the remote Docker host. That means that you will never be in a situation where your tests connect to the Kafka instance that you started 2 weeks ago and it's lingering for some reason on your BCCI machine. And then because the issues that will arise from that are really, really hard to reproduce and incredibly hard to debug and fix. So test containers libraries try to nudge you into the right direction with test containers tests to enable parallelization of tests nicely, to kind of nudge you into using the correct API to do the cleanup at all times. And in general, it's a very, very popular approach. Besides being just good library by itself, test containers comes with the ecosystem of the modules, where popular technologies have little implementation, like little libraries, little modules, which specify and encode how to run that particular technology in your code. So you don't have to figure out what you need to do to run Cassandra in a Docker container or Kafka in a Docker container, but you can just use the API and specify, give me a Kafka container, give me a MongoDB container, and you will get an instance of that immediately for yourself, which is great because that allows you to concentrate on the actual business logic of your tests without spending time on figuring out the infrastructure, because that is managed by test containers. And it's not just a Node project, right? Test containers is good integration tests are required in any ecosystem of any programming language. So what you can do, you can have the similar approach in your Java applications, in your .NET applications, in your Go application. There's test containers Python, there is test containers Rust. So it's a very, very popular and generic approach. And now I would like to show you a little bit how it feels to have tests and what are the building blocks of the API that you need to know to be productive with test containers. Let's look into the IDE. Right, so I have a very, very simple project here. It doesn't even have the actual application. I just want to give you the taste of the API and talk through what's important from the test containers point of view. Right, so we can just declare the dependency as normal to get that npm package. And here in our test file, what we can do, we can require test containers, and the basic building block is generic container. Generic container is an abstraction that represents the container that we can manage via test containers. What we need to give it, the Docker image name, which is the, in the current case, is Redis. We're going to run with the Redis container, and then we do the configuration. We can expose the ports. We can configure which files we need to copy into the container. For example, this is a good way to instantiate your database schema by sending it into your container. And then, of course, we have the methods to use and configure the life cycle of our containers, of our infrastructure that we need for the tests. So here in this just test, we are specifying that we want to create the container before all the tests. So this container will be shared between all the tests, which currently we don't have many, but we create the container, and then this is the interesting bit. The container can be run anywhere. It can be running on a remote Docker host or on your local host or in a VM somewhere. So when we make sure that our application knows how to talk to the technology, to the database, or in this case, Redis in that container, we don't hardcode any configuration, but we use that generic container instance to provide information where it's running so we can configure our application properly. So here we just say, oh, Redis, you're going to talk to Redis, the Redis client, sorry. You're going to talk to Redis by that host, which we get from the container, and the exposed port 6379 will be mapped to the high-level random port on the host side here. So we can say get the map port for that value, and then our Redis client is ready to connect to Redis. After all, we clean up everything, but we don't have to, at least we don't have to clean up the container, because test containers will, when our tests are passed, test containers will clean it up by itself. But this is still a good practice. If you want to spin up like thousands of containers during your test suite, maybe you should take care of the lifecycle yourself and stop them, so they just don't use all the resources at the same time. So the test itself is super simple. We just want to put the values into the Redis and get the values in Redis. And you can see that if I run my application, then we can see that the containers are there. So if I do docker stats, there's currently only the rook container, which is the container test containers uses internally to clean up for the cleanup purposes. So if I just do a very simple setup here, so I will run tests again, and you can see that the containers will be spinning up for a second and then running as well. So I don't run my Docker locally here. I use Test Containers Cloud, which is connected to a cluster nearby. That's where my Docker containers are running. And then if you want a larger example of our situation, then I have a different one. This is an actual Express app that uses MongoDB as the storage, and it just the tests are very simple. Let's look at the tests. We just use supertest to send a request, actual high-level functional tests for our application, and then we expect those requests to succeed, and then we expect the data back. So this is the very high-level functional tests. And the interesting part here is that we don't build the containers ourselves. We don't say how to configure MongoDB, but what we're doing, we're just importing the module that we can have. And if you look at the repository there, you can see that there are some modules that are for fairly common technologies: MySQL, Mongo, Kafka, Elasticsearch, Postgres, that are there, and they're not. It's not that such a large implementation. So if you're interested in any other technologies that you want to run, maybe after figuring out for your environment, consider contributing a module back. That'd be a great use. Right. So here we use Mongo, and you can see that how it works. So MongoDB container, we run, we await for that. Test containers node is idiomatic Node.js package. So async await is supported, of course, for all long-running complex operations like starting containers, waiting for the technology in the container to start. And then we configure our MongoDB client to use the connection string from our Mongo. You don't even need to know what exactly is the connection string or how it looks, what's the format of that. You just can run it. And this is very, very great. So now after that, we of course disconnect, and then we can run the tests. And here we run more tests. So if I run npm test here, you can see in the background, if the Docker image is not in the cache of my Docker daemon, then the image will be automatically pulled from Docker Hub, or Test Container supports the private registries as well, authentication, anything that you can pull with Docker would be supported, and then you can just run it. And then after everything is said and done, the containers are cleaned up and removed together with volumes and all of that. So it's a very, very flexible approach. It's very easy to integrate in your applications. You can also package your application in a Docker container, but I would prefer running it normally on my machine from my IDE, because then I can set the breakpoints and run it at will. So, and there's just one more slide. There is you can do the complex things. You can build complex topologies with network. You can wait for the database in the containers to start. You can create images on the fly. You can pull the logs and copy files back and forth and run the commands. Anything that works with Docker works with test containers. And I think this is really, really great approach. and you are welcome to check out the source on GitHub. And if you have any questions, or if you want to try and talk to the community, please join the Slack at slack.testmanagers.org to talk to the like-minded individuals. This is it. Thank you very much for watching. And if you have any questions, I'd be happy to answer them. Thank you.
Thank you so much, Oleg, for such a great talk. Join spatial.chat for a Q&A session with Oleg, and feel free to ask your questions there. Valmer, back to you.
Thanks, Cecilia. And a reminder out of our raffle, so tweet with the hashtag TestJS Summit. We'll be looking out for your tweets. We'll have a raffle of the conference t-shirt and Git Nation multipass at the end. The winner will get the t-shirt, as you can see in the picture here, and also a multipass, which gives access to a batch of Git Nation conferences. So it's your last chance to tweet and participate during the next talks. I'd like to have a huge round of virtual applause for our next speaker, Tsahi Levent-Levy, on his talk, Challenges on Testing and Monitoring WebRTC Applications. Tsahi is the person behind blog GeekMe and Chief Product Officer at Spearline. His blog focuses on rambling about technology, usually boiling down to WebRTC, CPaaS, messaging disruption, and other topics. To put food on the table, he's also a consultant in these domains. He publishes his own reports and runs WebRTC training. Welcome, Tsahi, and the stage is yours.
Hi, I'm Tsahi Levent-Levy, CPO at Spearline. I want to talk to you about the challenges of testing and monitoring WebRTC applications. Now, if we want to talk about that, we need to start with the question, what exactly is WebRTC? Especially in this type of a conference where what we do is talk about testing and JavaScript testing in web environments. And for me, WebRTC, this is usually what I would use it as a definition. A WebRTC is an HTML5 specification that's used to add real-time media communications directly between browsers and devices. Okay, so if I'm going to communicate with someone through the internet, inside the web or inside the web browser, I'm going to use WebRTC in order to send and receive media in real time. This is what WebRTC is for. It is a set of APIs that are standard-based that are available in each and every browser out there today. How are calls exactly made with WebRTC? We've got two people here. One is using a browser, and the other one might even use a mobile application or a mobile browser. There is a website of the application that they use in order to communicate with each other. The guy on the left here is going to send a message to the application server. And he's going to say, you know what, I want to invite that person to talk. Here is my offer. The server is going to look at the message. He knows where to find Brownhead on the right, and he's going to forward that message to him. Along the way, he can make changes to this message if he wants to. Now, the guy on the right here, Brownhead, received that message. He knows that someone is inviting him to a call. He also knows that this is Redhead on the left. And he knows what that person wants to do and what type of codecs, for example, to use in the call. Codec is what we use to compress, to encode and decode audio and video over the network. So he's going to accept the call by sending an answer. The answer again is going to go through the server to the other browser. Up until now, everything here is not really related to WebRTC, and it's just how things happen on the web. The magic of WebRTC comes next. And this is where actual real-time media is being sent directly from one user to another, and vice versa, in real-time interactively. Now they can communicate it directly with each other just by running these few messages before starting the WebRTC session. This is the only time and instance that a browser can send a message directly to another browser and not go through a server. Now, WebRTC sits somewhere between VoIP, voice over IP, and the web, the internet as we know it today, web pages. And that causes a lot of issues. That's because we've got here two different disciplines that are competing with each other. And it begs the questions for people like us that deal with testing. And that's, what exactly do we test and monitor? Are we going to use tools for VoIP testing and monitoring, or are we going to use web tools for that? And the answer is both, and it depends. Or it's complicated. So let's see what are the challenges that we need to deal with. And we start by understanding who the lead actors are and understanding that are out of our control as developers or as testers. First and foremost, we have the application. We've written it. We know everything about it. We're in control of that application and every piece of line of code in it. Then there is the users. The users use their own devices and their own peripherals. For example, to actually do this session, I'm using a Rode microphone, which is not the built-in microphone in my machine because it's better for these things. And I've got headsets because I need them to communicate with you guys. Then there's a network. You don't control the network. You don't own it. You don't know where the user is. In my home, because I do that all the time, I'm connected directly to Ethernet with fiber to the home, so I know that I've got a very good network. Other people might actually do these calls or try to do them from an elevator, a basement, or on the way riding a car. And that's going to affect what we're going to do. Last but not least are the browsers. You're already used to the fact that browsers are out of our control, but for people doing voice over IP, this is new. It's different, and they need to deal with that. Let's see how we're going to deal with each and every one of these challenges, and we'll start with the browsers. As you know, browsers update quite frequently. Most of them every month. In that cadence, we're going to get a new release of Firefox, of Edge, and of Chrome. Safari ends up being updated once every 1 to 3 months. As a developer, you can't go to Google and tell them, look, I've got this bug that I need to solve that I know that you're going to introduce in the next Chrome release. Can you please delay that release until I fix that bug? Not going to happen. They're just going to dump a new release of Chrome into the market, and that's going to be the end of it. Now, the problem with that is that with WebRTC specifically, each and every browser release is slightly different. They're still working on the implementation of WebRTC and of how that works over the network. That means that it is going to break your application probably once or twice a year, especially if you're going and using a lot of different features of WebRTC itself or taking it to the edge, to the extreme abilities of WebRTC in browsers. So the first thing we need to do is to decide or agree that we need to do browser automation in terms of testing. Why? Because we want to be able to repeat tests all the time and very frequently. In order to do that, we're going to use either Selenium or Puppeteer, which allows us to test and simulate and automate the scenarios that we have using real browsers. In voice over IP, for example, most of the testing is done using testing tools that are built to fit and are proprietary in nature. Most of the testing tools available in WebRTC are tools that are actually running on top of browser automation like Selenium and Puppeteer. Then we need to talk about networks. And networks are complicated. This is true for everything running on the web, but WebRTC is different because things happen in real time. If I send media, I expect it to be received on the other side in a sub-second latency. I'm sending it, I want it to be there on the other side in 100 milliseconds, 200 milliseconds, 500 milliseconds at most. Otherwise, it can't be interactive. Doing it at so low latency and at high bit rates, especially if it's video, means that there are things that are going to affect me that don't really affect web pages as much. That's going to be the bandwidth, the packet loss, and the jitter. I need to understand how much bandwidth I have available and then play with the bitrate that the codecs use to encode and send the media in order to meet these limitations that I have. I need to be able to deal with packet losses that happen on the network. Okay, if I send a web page to someone from a server, if he misses some of the packets of that web pages, that's not a big deal because then there is a retransmission that is taking place anyway. You're not even aware of that. You might get the web page 200 milliseconds later. But if I'm trying to actually talk to someone and there is packet losses, I can't even retransmit. There's not enough time to that. So how I deal with packet losses is vastly different with WebRTC. And then there is jitter, the rate at which packets arrive versus how they are sent over the network. The more jitter there is, the harder it is going to be to actually play it back on the other end. Now, all of these things that we need to deal with on the network need to come with another aspects in mind. The first one is geographies. If I have two people on a call, one of them is in Paris, the other one is in the United States, it would be wise if the server that connects them would be somewhere in between there and not in India. Okay, if we start playing with geographies, we need to understand where our users are, and we need to test where our users are. Then there's the part of the last mile, and I already alluded to that briefly in the past. If the user is far away from the access point, there is going to be a reduction in the bitrate, an increase in the packet loss and in the latency, and the quality is going to degrade. We need to test for that and see what happens there. If the last mile is ADSL or a 3G cellular network or LTE network, or just Wi-Fi, it has different characteristics to it, and we need to understand how our application works there. Why? Because we need high bandwidth sometimes, in large group calls, for example, and we need to see what happens if we don't have enough bandwidth on the network. How our application is going to behave in these cases. How is it going to degrade the actual look and feel for the users? Is it going to remove some of the people from being viewed, or is it going to reduce the bitrate for everyone and reduce the quality for everyone in the same way? So these are things that we need to be able to test for. Last but not least, all of these changes are dynamic in nature. Okay, I might have high bandwidth now and low 5 minutes into the session that I'm doing using WebRTC. Why? Because my son decided that he wants to play Fortnite in parallel to me doing this call, and I don't have enough bitrate on the network, okay? Or because someone else is happening in a shared environment, in a shared network, either locally or remotely. So what are we to do with all of these things? We simply need to take them into account. And that means that in our testing of WebRTC applications, we need to think about them globally and locally at the same time. We need to test for multiple regions and multiple locations, not only for multiple calls. So I want the calls to be in the US now, and now I want them in Europe, and now I want them in India. No, I want to do a group call with 2 people joining from the US, 2 from Europe, and 1 from India, and see what happens now with such a large group call. The other thing is that we want to have controls over the device that is being tested for its local network behavior. I want to be able to limit it by bitrate. I want to be able to inject packet loss or jitter into that device that I'm testing, okay? And I want to do it dynamically. So saying things like, let's start with no limits, wait for 2 minutes. Now we're going to reduce the bitrate to 100 kilobits per second. See what happens for 2 minutes. Then I'm going to remove the limit again. And I'm going to check how much time it is going to take the service to ramp up again to the highest bitrate that it can go in the network. Is that going to take 5 seconds, 30 seconds, 1 minute, or never? Okay, some of it are bugs like never, and some of it can be optimized further. And we want to have the tools and the means to be able to run such tests in a way that is smart. Then there is the user and its devices. And devices are different. There are different operating systems, different CPUs, different hardware acceleration, which we need for encoding and decoding video. Okay, that reduces the load from the CPU, for example. Different cameras, microphone, and display resolutions. The call will be very different if I do that on my desktop here on the table or if I take it from my phone. It's just a different CPU. The screen resolution is different. The camera resolution is different. All of these things are going to affect the type of test that I'm going to do. And there are several things that you need to understand and plan for. The first one, we need to manage device automation. We need to have virtual machines that we run with Selenium, for example, and they should be configurable with the number of cores that we have on them, the amount of memory we have available. we also want to be able to have raw camera and microphone simulation as part of it. Okay, think about it. If I'm going to use a machine, even a mobile device, running in some data center, and what I'm going to see in the camera is a static image all the time, the encoder isn't going to work much, and I'm not going to get the actual experience that is when someone is actually talking with a microphone, with a camera facing him. Okay, so it's important to deal with such use cases and be able to inject raw camera and microphone data into an actual test. Now, last but sadly true, you are going to do manual testing with WebRTC. You can't automate everything around WebRTC testing. Some of it will be manual at the end of the day, especially the part of using browsers that are not as easy to play with, Safari, okay? Or when what you're trying to do is running on mobile. Because doing mobile testing automation is hard enough, doing it for something that is as generic as WebRTC is even harder. Because we need to deal with microphone and camera and the audio environment of the device and where it is and what the camera is facing and the network of the device, and it's a lot different than doing just website testing on mobile devices. Then there's your application. And you can say, well, what's so different between testing the WebRTC application than any other web application? And the answer is, first of all, it runs specific workflows that you have. If you look at voice over IP, most of them use the same protocols, the same workflows, the same testing. So it was easy to build testing tools for that. With WebRTC, we need to do it as dynamic as the web, which is why we're using browser automation with Selenium and Puppeteer. The other thing about it is it needs to scale properly. From one call to multiple calls in parallel, or from a call with 2 users to a group call with 50 users in the same service. How exactly do you do that with your testing? And then there's the whole factor that we're connecting people. I'm not connecting a person to a website and he needs to go through a login phase, and then he needs to go to the e-commerce site, pick and choose 2 or 3 items, and then go fill out a form and click the buy button on the checkout cart. Okay? What I just described is something that a single user is using in front of a server. But think about it. If you're doing something with WebRTC, it's going to be interactive. There's going to be a call taking place. I am the teacher. I create the lesson. I join. After I join, the students are going to join the room, not before. If someone mutes, I want to see what happens to the others as he mutes. So it's kind of like it takes 2 to tango. I need to be able to synchronize between different browsers running in the same test inside the same session, because it needs to be orchestrated. I need to understand exactly which browser does what thing at what point in time, and one browser needs to wait for another in order to interact and do the things that he needs to do. And that means that you need to build synchronization mechanisms into the automation tools that you are going to use in order to test WebRTC. It starts with asking the question, who joins when, and being able to answer that. The answer is usually going to be, let's use out-of-band message passing. So I need to be able to send messages between the browsers that are not part of the application time testing. Saying something like, you browser number 2, please wait. And then once browser 1 ends and finishes something, it can send a message saying, well, I'm done, so that browser 2 can start his part of the process in there. Okay, so this out-of-band messaging passing is really important. Then you need to be able to spawn and orchestrate these tests at scale. It's not one browser or 2 browsers at a time. It's usually 10, 20, 50, 100, or thousands of browsers running in parallel. And these browsers require a lot of CPU and a lot of memory. Okay, usually you'll need 2 to 4 cores, so vCPUs per browser, to run a test that runs WebRTC to do a simple video call. Just bear that in mind. So the costs are going to be high, and orchestrating, allocating so many machines and getting the quotas for them in the cloud is not that simple. And then on top of that, you need to add expectations and assertions. I'm not going to just check that the web page came to the page that I wanted to. I need to actually validate that there is video. I need to validate that the packet loss is low, that the bitrate is at a certain threshold that I need it to be. So all of these kinds of assertions need to be added that are not part of the traditional web testing. They need to look at WebRTC metrics and from there understand and deduce if the test succeeded or failed. Now, something we don't talk about a lot, and this is the elephant in the room when it comes to WebRTC testing, that's going to be the predictability. If I'm running a test, I want to be able to run the test again tomorrow and get the same results. Okay, think about it. You're doing a manual test of a group call. You need to get 10 people to join a room. How are you going to get 10 machines joining a room? Through browsers. Are you going to ask people in your company to join? What is that testing exactly? Their network connection or your application? What are you going to do with the false positives? What happens if you try to run it tomorrow and one of the people is unavailable or is on a different network? You're not going to get the same results. So you need to bear that in mind and take that into account. You need to be able to build that predictability into your own application or into your own testing tools, so that once the QA runs a test, the R&D can run it again to get the same results, and the QA will be able to run it again to validate that the problem was fixed. The other thing is visibility. You want to be able to actually look at the results and understand them. You can't just take screenshots and say, well, it looks okay, the video. It doesn't work that way. You need to understand what goes in the underlying protocol of WebRTC itself. And that means that you first of all need to make your test repeatable. Okay, so if you run multiple times, it gets you the same results. And you need to collect and visualize everything. If we're used to doing things like machine performance and events from the browser and console logs, WebRTC means that we also need to collect WebRTC API calls and GetStats calls. GetStat is an API call in WebRTC that gives you internal metric statistics of the actual peer connection object, which is the connection, which is the object that is used in WebRTC. So you need to be able to collect all of these and then analyze them and visualize them properly. Now, you can do this on your own. There are open source tools to do that, or you can come, and I invite you to do that, to come to Spearline and look at TestRTC. We have products that do testing and monitoring for WebRTC-based applications, and that can speed up the work that you need to do. So thank you, and see you again.
Technologies and accessibility. He's also a curator of the online resource Tiny Helpers, Tiny Teachers, and contributes to a variety of open source projects and enjoys sharing nerdy discoveries. Stefan, the stage is yours.
Hello, TestJS Summit. It's time for another Playwright session. Playwright can do this. And before we get started, let me quickly introduce myself. I'm Stefan from Berlin, Germany, even though I'm in Greece right now. And I do front-end development, JavaScript development for quite a little bit. And I work for a company that is called Checkly. And we do API and end-to-end monitoring in the cloud. So if you want to maybe control and run Playwright on a schedule in the cloud to make sure that all your products are up and running at all times, you can have a look at Checkly. And I'm sure you will find that interesting. And let me tell you that I started testing, over 10 years ago. And these were the technology choices that I started playing around with. So my first UI and end-to-end tests were written in Selenium. And then at some point, PhantomJS showed up, this new fancy JavaScript-driven framework or library to control headless WebKit. And then later on, there was Casper.js. So we had a thing with Ghosts at a time, which was a testing framework on top of PhantomJS. And let me tell you that from the beginning, from the first possibilities to control a browser to test that the stuff that I actually put online works, I was a big fan of this approach, because the idea of end-to-end testing was always appealing to me, because you can test your websites and applications really from end to end, starting at the browser and maybe ending at the database, and testing and covering all the things in between, let it be APIs, web servers, or whatever you're building. When I wrote my first end-to-end test, though, it was a terrible experience. I spent, for example, sprint over sprint over sprint with my colleagues in my team to come up with a good end-to-end test coverage, only to create a test suite that was slow. We didn't enjoy writing tests and was flaky. And it was the absolute worst case scenario to end up with a slow test suite so that you have to wait 30, 40, 50 minutes to get a green light to maybe deploy a typo fix, but then also get false positives results so that you rerun your end-to-end tests to make sure that, well, maybe the tests just were not right and then they paste later on. You probably have been there. This is just the worst case scenario, that when you cannot rely on your test suite and it is also slow. So we were there, we invested a lot of time, and at some point we decided that it's not worth it. And we went for, hey, let's run the tests on demand, right? And maybe you have been there too, but this is the moment when you pretty much give up on end-to-end testing. Because what you want to do is you want to have your tests running all the time, on commits, on deploys. You want them to be on your radar at all times. And when you run them on demand, well, that is probably not often enough, so that you will end up with an outdated test suite very, very quickly because you forgot about it. And it's kind of negating all the effort that you put into place. And this is exactly what happened to me. Luckily, things got a lot better, right? Puppeteer was kind of the first step for official browser automation baked by Google for Chrome. And then Cypress a few years ago appeared with solid developer experience. And you might have guessed it. Well, for a long time now, I'm playing around with Playwright. And I think it's just a very, very decent solution for end-to-end testing. So let me show you what Playwright is about. In case you haven't seen Debbie's talk. So first of all, Debbie from the Playwright team talked about Playwright just a few moments ago. Playwright is a very inclusive testing solution. So it includes all major browsers covering Chromium, WebKit, and Gecko Firefox. It runs on Mac, Windows, and Linux. And you can write tests primarily in JavaScript and TypeScript, but if .NET, Python, and Java are your kind of thing, you can do that too. So from an inclusivity standpoint, Playwright is top notch. Additionally, if VS Code is your editor of choice, the VS Code Playwright extension plays very nicely to create Playwright tests, debug them, generate them, run them. You can all do all these end-to-end functionality and testing functionality right from your editor. So if this is your jam, you can use VS Code. So that is very nice. And it took me a while to realize that Playwright is actually more than a browser control. Playwright Test these days is a full-fledged testing framework that comes with the usual describe functionality before each, after each hooks, fixtures, test configuration. All these goodies are included in Playwright itself. So when you want to really go all in on end-to-end testing, Playwright is a valuable solution here. It's easy to parallelize. So remember my story of running tests and waiting for 30, 40 minutes. With Playwright, you can parallelize all your tests with a single CLI argument or put it in your configuration to speed up what happens and what is going on. And by far, my favorite is that Playwright is built for quick execution with features such as auto-waiting and web-first assertions. Because UI testing is usually that, well, you wait for something, you do something with it, and then you wait for the next thing to appear to do something with it then. And usually this meant that I had to put arbitrary delays here and there or manually wait for elements to appear or disappear. Playwright has all of this baked in, and this gets me very, very excited. Debbie briefly touched on this, but I want to show you how this works in this session too. So shall we have a look? Let's have a look at Playwright and run some tests. So we'll go to VS Code, and what you see here is on the right side, my terminal. And on the left side, we have TestJS spec.js file, which is a standard test file. And what we will test is this lovely website here, which is on localhost 8080. And it's the TestJS Summit site. And it's pretty much the same site, but now it includes this huge celebrate button because I think more websites should have confetti in them. Other than that, when we look at the project configuration or the project setup here, you will find a standard Playwright config here. And other than that, there's a test folder including TestJS spec.js. And this little facepalm.js is just my notes here in case you're wondering that. So we're not using the VS Code extension here. So to run this project and run the tests that are included in it, what you can do is npx playwright test. And you see already that there are 28 discovered tests using 5 workers. And we see already parallelization going on here. But we'll have a look at what happened here right now. So we see that there are 7 passed tests and 21 skipped. And when we look at the test file, we see that there's 1 official or enabled test and the other 3 are skipped. But why is everything multiplied by 7? So when we go to the playwright config, you will see that right now there are various and multiple browsers configured to be run when we run playwright tests. So there's Chromium, Firefox, WebCop, Mobile Chrome, Mobile Safari, Microsoft Edge, Google Chrome. So this shows that you can run all of these browsers with a single command. And to show you that this actually works is what we can do is we can pass the headed argument. And now we just see a bunch of windows popping up, emulating a specific browser and testing that all things are going well and are working properly. And I think this is already pretty cool to see all these windows popping up. But for now, I think we can just, let's disable most of the browsers so that we don't have to wait for them going forward. So what else do we have? Debbie showed in her talk that you can use the VS Code extension to generate tests. You can do the same thing from the command line pretty much too. So what I did here is I ran npx playwright codegen with a URL. And now what happened here is that the playwright inspector opened up. And now whatever we do in this little window here, let's click this here, let's do this and do this. You see that it's recording all the actions. So that could now go here, copy and paste this, add some assertions and get a quick and a head start using codegen if you want to do this. But let's have a look at the tests and start messing around with some tests. So what we have here is, first of all, a test that checks for the current page to have the correct title. And you see that there is a before each block that already goes to localhost. Then it checks the title, it locates the h1 element, and then it does a string assertion that the headline has the correct test. So when we now break this assertion here, let's have a look. What happens. So we can run this test and this will now fail because, well, tests, it will not have 3 S's here and we'll retry a few times here. But what we now see is that we have a failed test. So how could we debug this? Even on the command line, Playwright also comes with a debug mode. So what you see here is this browser session and again the Playwright inspector that allows us to step through all the instructions of the actual test here and to debug and see what is going on. And I think that's just a nice handy addition if you don't want to use the VS Code extension. So moving forward, what I want to show you is that first of all, Playwright has the normal or the common screenshot functionality baked in. So when you're running a headless browser, very often you're wondering, hey, what's the actual state of the website? So you can do the same thing. You can run await page screenshot to take a screenshot of the current page. And we now just generated a new PNG here, which includes the current status of this website. What is cool though is that Playwright has screenshot component visual regression testing baked in too. So what we also can do is what we have here is we have a locator for a headline. So let's do wait, expect. Now we can take the headline and we can say to have screenshot and let's give it the screenshot headline PNG. And what happens here is that we are tying an assertion to a locator. We're going to screenshot this particular element that is matching this locator. And then for following runs, we're comparing the screenshots. So this is visual regression testing with one line of code. So when I now run this, initially it will fail because there is no snapshot generated yet. But when we have a look at the result of this first failure, there is now a new directory that is TestJS spec.js snapshots. And you see now here this new snapshot that we just created. Going forward, when we now run the test again, it will always pass because Playwright will take a screenshot, we'll see if it's matching what we expect and moves on. So if we now just mess around a little bit with this screenshot here, which is the baseline for our comparison, and we run the test again, we will fail because we just messed with the comparison of the visual regression. And when we look into the test results folder here now, you see that this was the image that we expected with a lot of scratchy lines on it. This was the image that was generated in this current test run. And here we have the visual regression showing us, hey, something changed in your component that you have in your Playwright tests. And I'm still amazed that with a single line of test instructions, you can have component-based visual regression testing. To overwrite what we just had, what we can do is we can do update snapshots. And now we're back to the proper screenshot, which we will have here without scratchy lines so that all our tests are passing. So this is good. But let's move on and let's test that this very important confetti functionality is working. So what you see here is already that I have the button, that is the party confetti button, and I am locating all the canvas elements on this page. So when we look at this and we reload the page, you will see that there's actually quite a little bit of a delay for the button to appear. So what happens is that first of all, we have to wait for this button to show up. Then we have to click it. Then we have to wait for the canvas to render all the confetti. And after the confetti is done, also the canvas will be automatically removed. And this includes a lot of waiting if we would like to test this. But the nice thing about this is that Playwright has all the waiting functionality built in. So what we can do is we can leverage the web first assertions that come with expect, and we can say that initially we expect that there is no canvas element. Then we want to click the button, and then we expect that there is one canvas element and that there is no canvas element anymore. And you see here that all of these instructions are asynchronous. We have to wait them, but this looks like sequential code, even though there's a lot of waiting included here. So this button will only show up after a couple of seconds. Then the canvas element will immediately show up, but it will only disappear after a couple of seconds. And in Playwright, all of this is baked into the instructions itself. And I think this is just a wonderful way to streamline end-to-end testing code without putting wait fors and artificial delays everywhere. And you see here that we now have 2 past tests, and we can break this by doing this. But I think that's just a beautiful and nice way. So we can move on, and I want to show you something that I think is very, very cool too. So let's just fix the test again because it was broken now. So what you always can do in your test cases is you can always mess around with the network layer or with internals of the loading of a particular web page. So what you see here is that this test case get the page object in this test run. And you see here that we can listen for all requests and responses going in and out. So if we, for example, want to check the quality of our website and evaluate that there are no 404s or no 500s in API calls, what we can do is we can do a very quick status check. And if there's a status response that is greater or equal 400, we want to collect a URL and push it into an array that is not there yet. And let's create the array very quickly, const not found, and do this. And we have to push this. Here we go. And now we have to reload the page because it was already loaded. And then we add a quick assertion, expect not found length to be 0. And this is all it takes to make sure that there are no 404 requests on your page. So when we now run this test case again, let's see what happens here. Cool, our confetti test is slowing things down now a little bit, but it looks like we don't have any 404 resources or 500s in our little localhost websites. You can also do further stuff. You can start blocking requests. For example, if you want to speed up your end-to-end tests by blocking fonts or blocking tracking or blocking third-party requests because they are not necessarily needed in your end-to-end test suite at this moment in time. You can do that too with all the internals that Playwright provides you with the page on object. And then lastly, I want to show you how you can leverage native browser APIs to make sure, for example, that your website is fast enough. So what you see here is that I use the page evaluate function, which is the way to implement your own little data aggregators inside of this particular website. So Playwright already provides a lot of functionality, but if there is something that you're missing and you want to hook into the context of the particular website, you can always use page evaluate and give it a function that runs in the context of this particular web test case in this website. So what you see here is that I'm using page evaluate and I'm instructing a new performance observer to figure out the metric largest contentful paint, which is then passed back to the testing scope. And what we now can do is we can do expect, and I'm casting LCP to be a number because right now it's a string, to be less than, I don't know, let's take 800 milliseconds here. Let's run this. Let's see if it's fast enough on my local machine here. This looks okay-ish. Let's see. Here we go. Cool. And these were just a few things that I wanted to show you how you can get started with Playwright, running it on the command line if the VS Code extension is not your thing. So let's finish this up. So really, Playwright comes with so much functionality, includes auto-weighting, web-first assertion, screenshots, the test runner is nice, retrying, tracing, VS Code extension, inspector debugger, code image snapshots. There's really a bunch of functionality in there, and the team is releasing a lot. So watch out, there's a lot of things, good things coming. But we actually rerun Playwright every few minutes for our customers. And I just want to share some common best practices. So first of all, what we've seen is that short and idempotent scripts usually work better for the testing and the monitoring use case. So instead of having and testing your entire user account flow, what you usually want to do is you want to split that in different tests to make that easily to parallelize. So what we often recommend all our customers is that they should have a create, a login, an update, and a delete, all for their account properties or resources, so that all these kind of things can run in parallel. And this then also means that if one fails, you really know what failed, what's going on, and you get a nice little message, hey, this particular test case failed. And it's also very important that these kind of scripts are idempotent. What does that mean? I think it's a very fancy word, but this basically means that your test cases clean up after themselves so that you can run them repeatedly, which is very important for the monitoring use case. So whenever you create something, your test case should clean up after itself so that you're not cluttering a database. And these kind of test cases should run at all times. What we do exactly is we pair our end-to-end tests with low-level API calls. So for example, if we create a resource with the UI end-to-end, we usually have teardown scripts that then clean up all the resources that were created during a specific test on the API level. And we run this very, very successfully. And then as a hot take here today, I would like to share that it would be great if we start treating our UIs like we do our APIs. So for example, in software, we always talk about API uptimes, right? An API or an API provider is always very proud of number of nines and availability. This API is now up for 99.99999%. But I feel like we're kind of ignoring, or we're taking the front end layer not as seriously. And I think that the entire application that we are building should be tested at all the time. And it would be nice if we could have the same statistics for account creation, for account login, for account update, and account deletion. It would be great to see that, hey, my account creation tested with a browser works 99.999% of the time. And I think it would just be a nice way or a nice result if we would get there. And honestly, the technology that we use really doesn't matter here. If you use Cypress, use Playwright, use Property, but really just test all your properties, because I discover, unfortunately, enough bugs out there on the UI layer, and I think we can do better as an industry. But I probably don't have to tell you that because we're here at TestJS Summit. So with that, I think that end-to-end monitoring should really be your safety net, and your future self will thank you. My future self already does that, and I'm running low on battery now. So Thank you, everybody, for listening. If you want to reach out, my handle is my name, Stefan Judis. And if you have any questions, I'm always up for them. So with that, I talk to you very, very soon.
Thank you, Stefan. Make sure to join spatial.chat for a Q&A session, and you can feel free to ask your questions there. Back to you, Valmer.
Thank you, Cecilia. I know you've already heard about Multipass, so just a reminder that you can get remote access to all these great events. The pass will be valid for 1 year, so you can find more details on portal.gitnation.org. And let me introduce you our next speaker, Rafaela Azevedo. Her talk will be end-to-end tests for Web3 applications. Rafaela is a SC cleared full stack SDAT with plus 15 years of experience in QA, plus 13 years of experience in test automation, and plus 8 years in leadership, delivering and releasing software on different platforms such as mobile, desktop, and web. Rafaela became a STEM ambassador and a STEM Woman member in 2020, making an impact and bringing more people to the STEM area. Rafaela, the stage is all yours.
Hello everybody, I'm Rafaela and I'm gonna share a bit of my experience with end-to-end tests for Web3 applications. So just a bit about me, I have 15 years experience in QA, test automation, test strategy, architecture, and leadership. And I got really passionate about the QA area, so I created this blog in 2011, where you can find everything that I have learned in the past couple of years. So code snippets, programming, DevOps, leadership, and test automation, of course. I was born and raised in Brazil, to be more specific. I'm from a coastal city called Santos in São Paulo. And you can see the picture on the screen. I'm also a really big fan of Harry Potter, as you can see. And this is one of the reasons why I moved to London 8 years ago. And the weather as well, but nobody believes when I say that. But yeah, the agenda is going to be this one. We are going to talk about what is Web3, then the architecture of the Web3 application, some introduction about the end-to-end tests and the challenge, then the tools that you can use. And we are going to have 2 demos, one just using a mock and another one using a framework called Simpress. And then in the end, we are going to talk about the trade-offs of each approach. So what is Web3? Web3 is just a new version of the web. We are on Web 2 right now. And this Web3, it comes with the ideas of decentralization, token-based economics, and also blockchain technology. So it offers a read-write-own model. So people, they have financial stake and more power over the online communities they belong to. So they own the data, which is not the case right now. The online experience is expected to change as cell phones and smartphones and the PCs they did in the past. So it's going to be a big change for us that we are living in this moment. Some business, they try to join this new market, but they encounter some pushbacks, as with blockchain as well, like the negative impact on the environment and the financial speculation as well. This is the evolution of the web. So from the first version till now, so the first version we had the static read-only pages, where you couldn't interact too much with them. And then now what we have is a bit more dynamic and interactive, so we can go there and post things. So, on Twitter, we can just send our data away, basically, to these big corporations. And the Web3, which is the one coming now, is more private, secure, and decentralized. So the idea is, our data is not gonna be owned by these big corporations, but by yourself. And the architecture of the Web3 is also quite different because it's based on smart contracts like blockchain. So if we see now, what we have is basically the front-end, back-end database inside of this web server, and this is controlled by, the corporation or the company, somebody. And the Web3, we have just the front-end in the web server. So this is gonna still be a part of the, it's gonna be controlled by the company or the corporation. But then the smart contracts, the EVM and the Ethereum blockchain, this is something that is gonna be decentralized. And the smart contracts, they have the business logic or the protocol of these transactions and this business. So basically now what we have is just we are going to interact with the front end, and then the front end is going to interact with the smart contracts, and then EVM, the Ethereum virtual machine, and this is going to add the transaction to the blockchain. So it's going to add a new block to this Ethereum blockchain. And this is the part where it's decentralized. So this is an example of a Web3 stack. So we have some examples of like tools and frameworks, but you can see the layers. So you have, the first layer with decentralized applications. So it can be something like MetaMask, which is a plugin to authorize identity, have wallets. It's a cryptocurrency wallet. Then you have Uniswap, then you have another layer, presentation layer, which is called, then you have the developer environments where you can, test your product. And then you have the other layers like blockchain interaction layer and the network layer with the EVM blockchains. So this is not all the tools that you can use. It's just like an example with the most popular ones, I believe. But at least you have an idea of, how it is the Web3 stack. And then the tasks, they are, the end-to-end tasks are more like the problem with Web3. But if you want to do, the unit tasks is fine. You can use something that you already use it for, Web 2 applications. You can use Jest, you can use Mocha. It's still the same kind of framework. And then you can just verify, if the components, they are operating as intended. So UI tasks are also not a problem because you can still use the same frameworks that you use right now to do the tasks. The integration tests, they are not a problem as well because you can just use the smart contract libraries to mimic their own changes by just mocking the underlying EVM. So the problem is when you go and you try to do the full end-to-end tests without the mocking. Because you have this third-party provider that you need to use to communicate with the blockchain and submit the transactions. And most of the frameworks right now that do end-to-end tests, they cannot access this plugin. So one of the most used plugins is MetaMask, as I said, is a cryptocurrency wallet, and you need these to interact with the Ethereum blockchain and sign the private keys and do the full transaction cycle flow. So yeah, faking these UI interactions is really complex, and the test frameworks that we have right now, they don't support these plugins even when running headless browser. So one of the approaches that I'm gonna show you after is just mocking the Web3. But this is basically what is the flow. So the user goes interacts with the Web3 that interacts with the MetaMask or the third-party provider. And then finally, MetaMask is able to send this transaction to the Ethereum blockchain and add the block there. And these transactions, they are signed by a private key. So UI frameworks, they cannot do that at the moment as well. And one of the approaches is the using the Web3 mock. So now, well, it is a good practice anyway, not using the real third-party integration, because you shouldn't be like dependent on these. Because you don't have control of this third party, you don't have control of the plugin. So if it crashes or if there's a bug, you might need to pause your entire development just because you cannot test your own application full end-to-end cycle. So one idea is to mock the Web3 and then just do the same sending transactions and then simulating this part with the Ethereum blockchain. And then, yeah, with the Web3 mock, you can solve the problem by signing the transactions with a private key automatically and then sending to the EVM and the Ethereum blockchain. Another approach would be using this framework called Cypress, which is a wrapper from Cypress.io and has MetaMask support. But yeah, the problem of this, you are tied to use only MetaMask with this. Is the only third-party provider plugin that supports at the moment. And you need to use Cypress.io as well because it's a wrapper from Cypress.io. But at least you can choose between, locking the version of the MetaMask so you don't have unexpected failures, or you can just make sure that Cypress can just run the tests, but before that updates the MetaMask plugin just to have the latest one. So you can decide what you want to do, basically, if you want to lock the version or if you want to update with the latest MetaMask before running your tests. Which would be good to figure out, if your application has any problems with the new version of MetaMask. And you can still use any of other end-to-end test tools that are in the market already. The only problem is they don't have something like Cypress. They don't have a framework just to that is built on top of them, apart from Cypress.io, just to do the integration with this third-party provider. But you can use the mock strategy. So you can still use, for example, Tascafa, that I really like as well. You can use that and then mock the Web3. But of course, they have downsides as well. So if you want to use, some something different from MetaMask, you can use it with the mock. But then if you go with Cypress, the only thing that you can use is the MetaMask plugin. So now we are gonna just see the first demo, which is with the mock. So it's gonna be Cypress and the mock of Web3. Let me just go to the other screen. Oops. Sorry. This one. Yeah, this is on my GitHub, and it's just a fork from another project, but you can see already how that works. So it's a sample you just need to use yarn start to start the localhost web page, simple page, and then you can use yarn Cypress run to run the tests. But basically it's just this testing is sending the transaction is really fast, so you cannot see like properly. But the first one is just connecting to MetaMask. You can see the connect with the login, and this is the sample they created. So you can see here is expecting to have the address of the wallet that you connected. Then you are signing the messages as well, and then you need to check here, the data response, if it's exactly what you expect, and if it's doing the right transactions. And then in the end, try to send a transaction which you send to this wallet, this address, this amount, and then you should have, in this case, it's okay to have this server cannot send transactions, which was expected in this case. And then signing out as well, which you should be, is really, really simple, this one, but you can at least see how the mock is done. And this is the address, so if you want to have a look. And the other demo is gonna be using the SyncPress tool. So you can see that we are using the SyncPress, and we are really integrating with MetaMask. So this one is just running Cypress, and it's loading Cypress, and then it's gonna load the specs and just run straight away. So this is the MetaMask plugin. You can see that is starting and is not mocking. So if you go and install MetaMask plugin, you can see that is exactly like that. And also on the top you can see Chrome extension, so it is the real plugin. Then now was just setting up the MetaMask with importing the account, and now it is using the plugin to accept the connection request and just connect to this account. And now it's just creating the network as well. And basically this is another demo with the SyncPress. It's really straightforward as well, but it's well maintained. You can also check on the official SyncPress repo on GitHub. They have other examples there, if I'm not wrong. But this one is really simple and is on my GitHub repo as well. GitHub account, sorry. And of course, the trade-offs. So we have the test speed that we need to take into account. So when you use the mock, of course, it's faster than using the third-party plugin and waiting to load, and also the network, all the problems that you have when you are not mocking this third-party provider. Then you have the dependency on third-party app when you are doing the full real end-to-end tests. So if something crashes, if there is a bug, you might need to just, stop or revert the version that you were using before the bug, and you might need to pause. Or if you are really testing and you want to make sure that it's gonna work with the latest version, if there is a bug, you might need to wait until this bug is fixed just to make sure that is okay. And also end-to-end with, the end-to-end test with SyncPress is the real world test. So that this is really what the user is gonna do. They are not gonna mock, of course. And then the other one is mock maintenance. So you need to worry about that if you are mocking, just to keep, up to date, if you want to make sure the latest is working with your app. And then you have the test app in isolation as well. So when you do with the mock, you don't care about this third party if it's working or not. Then you are making sure that your app is always like working fine. You don't need to pause. You don't need to stop your development. You don't need to worry about the third party to be fixed or anything like that. It is a good practice anyway to do that, to mock. So one thing that you can do as a strategy is just to have a good balance between the unit tests, the integration tests, so you can mock most of the tests, and then having, I don't know, maybe 10% or even less of end-to-end tests. So you can use something, for example, the framework, and automating these 10%, or you can have some exploratory tests doing the full end-to-end, or you can just have manual tests for that. It's really up to you, your project, the strategy that you use, what are your needs. But a good balance, always make sure that, okay, we cannot test end-to-end with the latest version of the third party, but we know that with our integration is working fine. We have everything covered, so it's more robust, it's more trustworthy in the end. And yeah, that's it. So thank you. If you want to connect to me, in any of these social medias, just feel free to do so, or send any questions or feedbacks. I'm open for these as well. It's always good to improve. So yeah, that's it. Thank you.
Thank you, Rafaela, for such an excellent talk. Remember to join Discord for the Q&A sessions with Rafaela. Feel free to ask questions there. Go to Q&A testing localhost track channel on TestJS Summit 2022. And now you can join the production track. See you there.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to...
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
see's my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bitter bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Loneliness creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk.